So we collect data, and before collecting data, we must validate our measurement system. Sometimes our measurement system itself may be weak. We first ensure measurement system, then we collect data, then we calculate baseline. Baseline can
Sir,
be signal.
baseline means central tendency value, or
No. Baseline means your current level of performance.
current level of performance. Okay.
You want to arrange a tuition teacher to your child. How much your child is currently scoring? If your child is currently already scoring 90, then you really require a better teacher to improve the performance further, isn't it? Because already the base level is how much? 90%. From 90, you want to improve to 95 and above. That's a different situation. And from 30 to pass mark is a different situation. So baseline, where are we standing as of now with respect to rejection rate, with respect to DPMO, with respect to yield, with respect to CP and CpK, with respect to sigma level? All questions finally gives the same meaning. But depending on the industry, depending on the terminology, we use different tools, right? That's it. So now, always collecting data which can give more details is a good idea, isn't it? Collect data in a way that it gives more detail. For example, if I only collect detail about whether the students have passed or failed, it's not giving me more detail, isn't it? I only know the student has passed and a student has failed. But by how much mark he passed, but by how much mark he failed, then I get a good idea, isn't it? So same manner, when you collect the data in a way that it gives more information. So generally measurable characteristics, give more information. You measure temperature, you measure pressure, you measure diameter, you measure cycle time, you measure lead time, you measure your response time, you measure your transaction time. So you get accurate information of what is happening. If you don't measure, simply ask people, then they will say it is good. Someone will say it is bad. You are not getting accurate information, isn't it? You are only getting approximate information. So accordingly, the data quality will differ. So let me take you through the presentation and then you understand better. So there are a few things you have to gain the clarity here. One is data type. Another one is the instruction that is used to collect the data, which is known as operational definition. And then we move with measurement system analysis. Yeah. So here, so the first thing is in measure phase, identifying what to measure. That is, your CTQ should be very clear. The CTQ should be clear to you. And then you should have a data collection plan. And then you should know its data type and operational definition. Oh God. Yeah. So CTQ means are the key measurable characteristics, of a product whose performance standards. Just a moment, I'll share it again. I think so many screens are opened. I'll close. Okay. So CTQ are the measurable characteristics of a product or a process. Yeah. Whose performance standards or specification limits must be met in order to meet the customer requirements. Okay. So it may include the upper limit and the lower specification limits. You know, if it is diameter, yes, the customer will give the specification, will also give the upper limit and lower limit. Now data. Data can be continuous or discrete. Continuous means measurable. Discrete means countable, right? So for example, if I ask you, what is your height and what is your weight? How do you tell me the height and weight? By measuring, right? Then the data is continuous. When I ask you how many mobile phones you have, how many laptops you have, or how many customers you attend every day, all these informations are countable. The countable data are known as discrete data. Hope it is clear to all of you. So the broad classification is data can be qualitative. Sorry. Yeah, data can be qualitative and data can be quantitative. So qualitative means if I collect all your name. Yeah, I collect all your name and type it in Excel sheet, then it is qualitative data. Your native place, qualitative data. Your company name, qualitative data. But I collect your age, that is quantitative data, right? And the data can be qualitative and data can be quantitative. And within quantitative, there are two possibilities. One is continuous, another one is discrete. Continuous means measurable. Discrete means countable. How many children you have? And the answer is a continuous data or a discrete data? Discrete data. You all give feedback at the end of the training program. Is it a continuous data or discrete data? What is your
discrete?
Discrete data. Yeah. So
But
now,
what is the point that differentiate between discrete and continuous? Just with an example, because here also there is a number, there on the right hand side also it is a number. So what makes it different?
the number is there, but in continuous data, decimals are possible. In discrete data, no decimal. In continuous data, there will be a unit of measurement. In discrete data, there won't be any unit of measurement. Right? So accordingly, there are some limitations a discrete data will have. But continuous data will give more accurate information. Continuous data will give more accurate information. Now let's do a small exercise here. You can try to classify the data here into continuous and discrete. And tell me turnaround time. Do you think it is continuous data or discrete data?
Continuous.
Very good. Customer satisfaction score.
Discrete. Discrete.
Yeah, customer satisfaction score is discrete. And number of transaction failed.
Discrete.
Discrete.
Discrete. And maturity amount.
Continuous.
Continuous. Total available balance.
Discrete.
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 Total available balance in your bank account is continuous.
Yes.
Because it can have decimals, because it is having a unit of measurement. Time to resolve a complaint.
Discrete.
Continuous.
Time is measurable, continuous. Number of credit cards that are linked to savings account.
Discrete.
Discrete. And time taken to process a loan application.
Continuous.
Number of clients attended.
Discrete.
Now you know how to differentiate continuous and discrete. So which can give you more accurate information? Continuous data or discrete data?
Continuous.
So ensure you collect, you give preference to collecting the information in the form of continuous data, right? Because the discrete data will have some limitation. So continuous data can give more information. So unit of measurement will be available for your continuous data only. Whenever you have a unit of measurement, then it simply means your data type is continuous. Operational definition. So operational definition is nothing but a clear and concise, understandable description of what is to be measured and what is to be observed. Say, for example, if you want to measure the length of a product, then there has to be an instruction which should make each one of us understand the meaning of length in the same manner, isn't it? Because all of us are know, see, length we all know. The length means the dictionary meaning is there and everything is there. But in our project, what do we mean by length? Let's say the collar length. Now, collar length means what? We have to define. Suppose if the project is reducing waiting time, what is the waiting time we are talking about? That everyone has to have a same understanding. And then only, our data will be proper. So see here, there are a lot of CTQs here. Time metrics available, order lead time, order percentage of late lunch hours, order preparation time, food cooking time, customer waiting time. Is that all are time? Does it mean all are same or different?
Different.
Different.
Different. So we need to have a proper clarity. If we don't understand, then sometimes we may measure an irrelevant characteristics. That should not happen. Say for example, customer waiting time. Can you please read through the definition of customer waiting time, and then you are able to understand what exactly it is, and so that you can actually know. Only when you can understand, you can measure. Please read the customer waiting time, and then one of you please tell me how can I measure the customer waiting time.
So the time from when the customer arrives through the front door, not when the customer puts their name in, there could be a line, to when they are seated. This can be monitored on the security video clock.
Okay. Now, if you want to measure it with this understanding, will you be able to measure accurately?
No, sir, we will not be able to measure.
So what is it telling then? Time when the customer arrived through the front door. Do you think you will be able to capture the time at that moment?
Yes.
Until the time the customer is seated.
Yes.
That moment can also be captured.
Yes.
Yes.
That means you can accurately measure. That means you can accurately measure, isn't it?
Yes.
So according to the project, it is happening in a restaurant. The project is happening in a restaurant. They are trying to minimize the customer waiting time. And the definition of the customer waiting time is the moment any customer arrives through the front door, and then the moment he is actually seated.
Seated.
Many things can happen in between, isn't it?
Yes.
That is not, that is not,
Pot.
yeah, we are not interested in those things. The moment someone enters through the front door of your restaurant, then, the waiting time clock starts running. Whether the fellow meets the manager or not, still it is considered as waiting time. Why are you measuring in this manner? Then only the manager, will try to meet him. Isn't it? Actually, he has to meet the manager so that the restaurant manager can offer a seat. So according to the project, we wanted to minimize this, what do you call, the waiting time. So now let me play a short video which will help you to understand why it is important to have a proper understanding of the characteristics to be measured. Module 1, I'll close. Closed. Okay. Actually, I have received this video in WhatsApp. I thought I will use it here.
It's convenient. I'm an old man. Gopal Sukumar has given me a job. Hey, collect the data, see our training course is very good or not. Then what I will do, not here, but in the actual class. Then I'll sit on my chair there in one place corner. And then whoever crosses the room, I will ask, hey, how is the lecture? I will not go to the person's chair and then ask him because I am old. This is again a convenient way of testing. Understand? Yes or no?
Right.
But what you should do, you should collect the data from the different groups in the population. I'm not supposed to ask only from one particular data. That is why we call it as a normal distribution. You know how the normal distribution is like this. Entire range, I'll have to go from one corner to the other corner, one end to the other end, and take samples from each place. I should not select samples only near around the mean. I should not select samples only from one left-hand side corner. I should not select people only from the right-hand side corner. Like, for example, in an university, I want to find out the performance. I want to find out some opinion. There may be day scholars, there may be hostelers. Even in the hostelers, there may be hostelers sharing a room. There may be hostelers staying in a single room. Yes or no? So I have to select all the, there may be boys, there may be girls, right? There may be postgraduates, there may be married students, there may be unmarried students, bachelor students. So I have to find out all this and then take that is what is called, you have a random selection covering of the entire range. Okay, independent should be there. That means everyone has a chance of being selected. Understand? Clear? Equal chance of selection should be there. That is why this statistical analysis, very many important things are there. First of all, you should select the sample size, appropriate sample size. If the population is only 30, for the group performance here, only 34 students are there. In order to find out the characteristics of this group, I should not take sample, because all the 36 I must study. I must find out all the performance of all the people and then find out the average. Then only I will give the correct data. So my report will be perfect only if I take the sample size as the entire population, all the 34. If it is more than 100, then I have a sample size. I have to select the sample size, right? And that sample size depends upon any function is depending upon the input variables. Yes or no? Depending upon the sample size you select, your result will be accurate. That way you can select all the people, your result will be accurate, 100% accurate. But we don't have time for selecting all the population, because population may be sometimes infinite. I want to find out the average speed of an auto driver in Chennai. What should I do? There will be 10 lakhs auto drivers. Can I connect all the 10 lakh auto drivers and then ask the speed and then find out the sum and then divide by that lakh of people? Is it possible? By the time the speed will change. Yes or no? Therefore, I have to have samples. What I will do, I will select a sample of 10 auto drivers from my area, 10 auto drivers from other area, 10 auto drivers from a different area. So like that, I will select 10 samples and then find out the average. And from this, I will give the estimation about the Chennai auto drivers speed, average speed. Am I correct? Yes or no? Therefore, sample selection is very important. Sample size is very important. And then the data collection is important. And then comes the analysis and your result and report. Okay. Even if one thing goes wrong, everything will go wrong. I think I have completed, Gopal Shukumar. You can continue. In case you have any doubts, you can ask me.
Yeah. So that means there are different sampling techniques available, right? And you need to make the right judgment. Which kind of sampling technique is better? Normally, the random sampling is one thing. Hope all of you know what is random sampling, isn't it? So you randomly select sample. That means people really cannot judge which sample will you choose, right? Which sample will you choose? Every sample has an equal chance of getting picked up. Every sample has an equal chance of getting picked up. Say, for example, if I always interact with people who are on video, what kind of sampling it is? I always talk to people who are on video.
Selective.
Selected.
Right? You can say purposive or selective sampling. But if I also ask question, even people who are not on video, randomly I just call someone, hey Rajesh Kumar, what is this? Chetan, what is this? Then that means it's a random sampling, isn't it?
Yes.
So when I ask question from people who are on video as well as not on video, that means each of the participant has equal chance of getting, a question.
Question.
So this is sometimes helpful. This is sometimes helpful. And whenever you are not very clear about which sampling technique will work, then you have to go for the random sampling. Right? If you are not very clear, then you have to go for the random sampling. Sometimes it is systematic. What is systematic? Let's say every morning, 10 o'clock, you go there and then you take a sample. What is this sampling technique? Every morning, 10 o'clock, you go there and then you select sample and come back. What is this sampling technique? Is it
Select-
systematic sampling or random sampling?
Systematic.
Systematic.
Systematic, right? But you probably may have to understand little more. 10 o'clock, going 10 o'clock is systematic.
But you are picking the sample as a random.
The sample what you pick is random. So the first
Yeah.
sample you pick at 10 o'clock is random. But after a sample is picked, every 100th piece comes to your table. That is systematic. It is a combination of, can you see here? It is systematic and then
And
random
random.
mixed, isn't it? So always, with all this knowledge available, you have to formulate a sampling method for yourself. For your case, you come out with a sampling technique which can help you to understand the ground reality properly. Sometimes we go for a cluster sampling. Sometimes we go for a stratified sampling. Let us say you produce products in 3 different lines. There are 3 different lines. A product is getting produced. And now you collect sample from all 3 lines. Then it is stratified sampling. You run 3 hospitals. And then data comes from all 3 hospitals. Now, what is this sampling? Stratified sampling, isn't it?
Certified.
You have 3 lines, 3 machines, 3 doctors, 3 hospitals, 3 laboratories, and data comes from all the laboratory. That is stratified. Sometimes it is cluster. Let's say you have 3 laboratory, but you don't collect data from all the 3 laboratory, but you randomly picked up 1 laboratory and then you collected the data and came back.
Random.
Analysis. You randomly picked the lab, but collected data from that particular lab only. This is called cluster. When you have multiple groups available, but you collect data only from one of the group. That is called cluster. Then you have 10 factories. You have to go for auditing, but you don't have time. You can't really audit all the 10 factory. But communication was done that audit will happen next week. Now, out of the 10 factory, you yourself randomly pick 2 factory, and then you did the auditing with those 2 factory. Remaining 8 factories, you are not doing audit, but you randomly picked 2 out of the 10, and the auditing is done, report is generated, and the process is completed. Now, what is this sampling? You have not gone to all 10. If you have gone to all 10, then it is stratified, isn't it? But you picked up only 2 out of the 10. You picked up 2 clusters out of the 10. And then within the cluster, you collected the sample or you did the study, and this is called cluster sample. Picking only one or two groups out of the possible groups, and then doing the study there, and then taking the decision. This is called cluster. So these are the different types of sampling, but ultimately we can't say this is the best one for your project. No, you have to finally decide which is going to work better. Correct, all of you? All of you, do you understand?
Yes, sir. So one clarification. When especially this is related to the systematic sampling. See, as we know, we will be going to a line to collect the sample at a particular time, and even there will be some instances where the what kind of testing has to be done for that particular sample, what we are collecting at that point of time, is also there, right? They will specify, because as a continuous quality process, they will be defining that also. So is there any different name for that, or it comes under systematic sampling? That is what I wanted to know. For example, I'll give an example. See, in our process, what happens is the moment we make a solution, I will very simply, I'll try to put it in a layman language. When we make a solution, at every point of time, whenever we make X solution, we will have to check its pH. That is what is very clearly defined in the process. So that is what, under what category that will be coming? Will it be a systematic sampling or it will be different?
So every time you prepare a solution, you test it, right?
Yes, we tested, and that is what has been defined as a quality procedure.
Is it a sample you study, or is that sample only, right?
Yeah, it is whenever we make because at every stage there will be an in-process quality check we call.
Yeah.
So we will be taking samples and we'll be checking. It will be sometimes pH, it will be other parameters which we will be checking because it is a biological product. So it is not like a regular what I can say the testing what we do, since biological product, a lot of variations will be there from process to process. So that is the reason. So how is there a different name or is it something comes under systematic sampling only?
Sir, can I come?
Yeah, sir.
Sir, please note, I think we are getting confused with whatever you say because testing is one. What you test is something different. We are not at all coming into picture. You are the king there. You are measuring the concentration, you are measuring the density, or measuring the taste. It is not our concern at all here. Yes or no? Okay, understood. Clear?
Right.
That is purely a technical aspect. What we are doing is that whatever you test, the testing should be in a particular order. It should be random. When I say systematic, the systematic sampling is not a good sampling method. When I say that every morning 10 o'clock, I am going to measure this PA, right? Then every morning 10 o'clock, the operator will be very careful. Hey, now is the time RK will come and inspect. So that he will ensure that that particular bottle has got a very good PA. Yes or no?
Okay.
There are chances for cheating me. I'll be thinking that I'm doing a sampling and then sampling is coming out perfectly all right. Okay. Therefore, the randomness should be brought everywhere. Right? The randomness, I think in your case, I can tell you that today morning I come and I will test only PA. Tomorrow morning I come at 10 o'clock, I will test some other characteristics. You can do that. That is called random testing, right? Or not 10 o'clock only. Today at 10 o'clock means tomorrow I may come at 10 o'clock or may come at 11 o'clock. So that randomness should be there. And every test has got the equal probability of being selected. Today, I can take either pH test or concentration test or test, anything. Tomorrow also, I can take either this or that or the other one, equal likely chance, right? So equally likely chance should be there for all the tests. And then randomness should be there. And it should be covered in the entire range because not necessarily because your production is taking place over 24 hours. Yes or no?
Yes. Yes, sir.
Then taking a sample exactly at 11 o'clock, it doesn't produce any good for me. Therefore, I can select a sample, one sample at 10 o'clock, another sample at after about 1 hour, after about 2 hours. Like that I can take, right? I need some more like some cluster sampling. Cluster means I'm selecting the entire group, yeah, that's all. Cluster means, suppose here there are 36 people. I group them into aged above 36, aged below 36, and above 20, and below 20. I can select any one of the cluster, yes or no? Below 20 or 20 to 36 and above 36. I select one cluster above 36 and then ask all the people above 36 and do the sampling. Then it is called cluster sampling test. Clear? Understood?
Okay, sir. Okay.
That is what is called cluster. But I'm leaving the other clusters. Right. Therefore, stratified cluster. What do you mean by stratified cluster? I'm grouping them, and from each cluster and each group, I'm taking a few randomness. Right. Therefore, there is no one particular testing which is ideal for this thing. You can mix up the sampling techniques. Randomness should be brought. Right? Understood, sir?
Yes, sir.
Thank you.
Yeah. And more better the understanding about the requirement, and you will know which sampling technique will work better and which combination will work better. All right, so now we move on to the another topic, measurement system analysis. Can one of you tell me why should we analyze the measurement system? Because we need to know whether the measurement system is first of all fit. Isn't it? Sometimes if there is a problem with the measurement system, automatically your data will become useless. Say, for example, I conduct a test and all of you write the test very well, but still, the result says everyone has failed. That means there is no problem with the students, but problem with the measurement system. Isn't it? So we have to correctly pass the students who wrote the exam well, and we should also correctly fail the students who write the exam poor, isn't it? If you don't write well, then you should be failed. If you write well, then you should be passed. So same manner, our measurement system should categorize a good product as good and bad product as bad.
Right.
So the reading has to be accurate enough. So when we say accuracy, we need to measure something called bias. So what is bias? We are going to understand. And when one requirement from the measurement system is accuracy, the other requirement is precision. Both are important. Accuracy is also important. Precision also important. So what is precision? Precision means consistency. Precision means consistency. So we will and again, the consistency can be measured in terms of repeatability as reproducibility. If you are using only one appraiser, then precision simply means repeatability. If you use multiple data collector, then precision or consistency means you need to understand the repeatability as well as reproducibility, and together repeatability and reproducibility together is known as GAGE R&R. So all this terminology we will now try to understand. Probably before lunch, we'll only try to understand bias, and after lunch, we'll come to all of this. So first thing is bias. First of all, why measurement system analysis? We are trying to understand the problem. We want to know the baseline. So when we want to understand the problem, we should have a quality data. Because we see the problem through data. Like while driving a car, we see the road through the windshield. Now windshield should be clean and clear. Then only we can see the road. Similarly, when we try to understand the problem baseline through the data, our data must be clean and clear. This is what we call it accuracy and precision, right? So if your data is not accurate and not precise, it means you are aiming to drive a car by closing your eyes. We should not do that, right? So, but getting perfect data is difficult. So generally measurement error to the level of 10% is considered permissible, but the lower is better. This 10% is an industry guideline given by an organization called AIAG. According to them, the measurement error should be less than 10%. So we normally do an analysis called measurement system analysis to ensure that the project team focus accurately on the process variation and ensure that improvement efforts are used efficiently to reduce the process variation. Otherwise, what happened? They'll be putting efforts and later realize that the problem is not the problem at all. All the problems are considered a problem because of the problems in the measurement system. That is also possible, right? So in that case, finally, they will end up correcting the measurement system. So our effort should not, get wasted. So after MSA, you can see better and understand the process conditions better. So that's why MSA is done. In MSA, one type of study is studying the accuracy. In order to study the accuracy, you need to calculate something called bias. Imagine you have a wristwatch. You have a wristwatch, and that helps you to understand, find out the time. So let's say right now the correct time. What is the correct time right now? 12:55.
12:59.
12:59.
So it's already 12:59. Let's say I'm asking what is the time, and someone is looking at the watch and he's saying that The time is 1:10. That means there is a bias in his watch, isn't it?
Right.
Correct time is 12:59, but his watch is showing 1:10. That means it is 11 minutes faster. This is called a positive bias. If I ask the time and the correct time is 12:59 and he says time is 12:50, that means in this case it is negative bias. So bias can be positive, bias can be negative. So if you know the bias, you can still wear the watch. Say for example, your watch has a bias of 10 minutes. If you know the bias is 10 minutes, by 1 o'clock it will show 1:10. Then by 2 o'clock, it will show time as 2:10.
2:10.
At 3 o'clock, it will show the time as 3:10. If you know the bias, and if the bias is constant, you can still use the measuring instrument. You can still use the measuring instrument because you can simply add or subtract the bias to get the accurate value. If the bias is plus positive, then you subtract all your measured value by an amount equal to the bias. 3:10, you minus 10 minutes, time is 3. 2:10 minus 10 minutes, time is 2. In all cases, you are able to get the accurate time. All of you understand?
Yes.
Yeah.
So bias is manageable. And converting your measured value into accurate value by adding or subtracting the bias, that is known as calibration. You can calibrate your data and then you can get accurate values. You can calibrate your data and then you can get accurate value. And that calibration procedure will be easy and simple if the bias is constant. Isn't it? Because you just have a one formula. All the observed value minus 10. That gives you accurate value. Isn't it? So ultimately, we are trying to nullify the bias. Can you see that, all of you? We are trying to nullify the bias. If the bias is 0, your data is considered accurate. And it is only in order to achieve the bias or make our readings accurate, we always take multiple readings. We take multiple readings only to make our readings more accurate. In your school days, college days also, you might have wondered why our teacher is asking us to do the same experiment 3 times. Have you did that, isn't it? In laboratory, we do the same experiment 3 times and then we have 3 value and we calculate the average of the value and that average will be applied in a formula. Why your teacher has advised you to do that? Because the bias can come down, isn't it? You take 3 reading and calculate average and automatically the bias will go down. So if you want to calculate the bias in your measurement system, you definitely require the standard piece. See here, a standard. A standard of 25.4 is checked 10 times by a mechanical inspector using dial caliper. And 10 readings are available. You can see that. 25.4 is the true value. That means 25.400. And look at the 10 reading. Can you see the variation in the data?
Yes.
The piece is standard, but still there is a variation in the data.
Right.
That means the variation is due to measurement
Measurement.
variation, which is known as measurement error. Now, how
Error.
much is the bias in my measuring instrument? To calculate the bias, first thing is you should calculate average of the 10. All 10 values, the average is calculated. You can see here. Average is calculated. Now bias. Bias is nothing but the difference between the average of the calculated value or average of the measured value minus true value. The difference between average of the measured value minus the true value. So measured value and true value, the difference is 0.0051. So 0.0051 is considered the bias. If you understand how to calculate bias, first of all, to calculate bias, you need a standard value. You need a standard value. And then with the help of the standard and measuring instrument, the data, the readings are taken and calculate the average and find out the difference between the average and the standard value. That will be the bias. And now bias sometimes expressed as percentage of the tolerance. In this case, you can understand the tolerance is plus or minus 0.25. Tolerance is plus or minus 0.25. So total tolerance is 0.5. With respect to the total tolerance of 0.5, my bias is 0.0051. That means how much is the bias as a percentage of the tolerance? 1% of the tolerance is the bias. And the industry standard says measurement error should be less than 10%. Now, how much it is? 1%.
1%.
So all of you understand how to calculate bias?
Sir, one question.
How calculate tolerance 0.5?
How? Come again?
Tolerance 0.5. How does?
No,
This
you
one-
asked
0.2,
me
0.22. Plus or minus 0.25 into 2.
Yeah. Plus or minus 0.25. Yeah. The plus or minus 0.25 means right side 0.25, left side 0.25. So the total working range is 0.5. Clear?
Okay.
Yes, sir. Yes, sir.
That is called the tolerance. Sometimes, they give customer tolerance or any tolerance that is given.
Sir, can I come?
Yes, sir, please.
Please note this standard deviation or deviation, we say it has no signature. We say only a number, 2 mm. When I say deviation is 2 mm, the deviation can be on the plus side or negative side. Standard deviation, if I say standard deviation is equal to minus 0.2 millimeter. Am I right? Right or wrong? Tell me.
Okay, sir. Your voice break. Please repeat again.
I am saying that deviation has no signature, no sign, positive or negative sign, it will not be there. Deviation is purely just a number with unit. 2 mm. Deviation is 2 mm. Means deviation can be on the upper side or on the lower side
Yeah.
also. On the
2 mm
positive
deviation
side,
means it can be plus 2, it can be minus 2.
minus 2. So suppose I am saying my standard deviation
range
is
is
2
4.
mm. My standard deviation is minus 2 mm. Am I right or wrong? I am wrong because standard deviation has no negative sign. Understood?
Okay.
Standard deviation is always a number with unit. That's all. 2 mm standard deviation. No plus 2 mm, no minus 2 mm. That's always plus side only. Okay? Understood?
Okay, sir.
So here after any measuring instrument you use, first of all, you should know whether there is a bias in it or not. If there is a bias, you need to know how much it is. And if you know how much it is, and if you know that is going to be the bias, while using the equipment, then you can create a calibration procedure. The calibration procedure is we measure data, and then from all the measured value, we subtract the bias. If the bias is positive, we subtract. If the bias is negative, we add. Ultimately, we get accurate value. So this is called data calibration. If you want to avoid data calibration, you can calibrate your measuring instrument. Am I right? If you don't want to subtract or add or subtract the 10 minutes, you have to reset your watch. Am I right? If you reset your watch with the correct time, that is known as calibrating the measuring instrument. Why are we calibrating? To nullify the bias.
Bias.
We want to make the bias as 0. And so we need to calibrate our measuring instrument at appropriate interval. Some measuring instrument we calibrate once in a year. Some measuring instrument we calibrate once in 6 months. Some measuring instrument we calibrate once in 3 months. Because we know the bias, the bias has to be adjusted. See, the calibration is required because, if the bias start behaving dynamically, if the bias behave dynamically, then it will be difficult for you to arrive on a formula. Am I right or not?
Yeah.
If your watch is always 10 minutes, then it is easy to use the watch. But if it start, behaving very dynamically, at times it is 10 minutes, at times it is 40 minutes, at times it is 2 minutes. Now you don't have a formula, isn't it? So this is called, linearity or stability. This is
So
called,
this
linearity or stability. We want the bias to be constant over time. That means, our measuring instrument is stable. That means our measuring instrument is stable. Stable means our bias is constant over time.
Time.
Similarly, if the bias is constant over the range of the reading, you know what is range of the reading? You might be measuring 1 ampere current. You might also be measuring 10 ampere current. So 1 ampere, 10 ampere, even 100 ampere. In all, the range is 1 ampere to 100 ampere. You have an ammeter. Is this ammeter measure current with the same amount of bias throughout the range? If the bias is same throughout the range, then it is called linear. The point is, even with a new instrument, getting the linearity is a challenging task, right? Getting the linearity is a challenging task. So bias over time is stable. If the bias is constant over time, it is called stable. And if the bias is constant over the range of the reading, it is called linear. So, but if the bias is not linear, then the problem is known as linearity problem. The bias is not linear, it will become non-linear. So we will if you really wanted to make your measurement system more accurate, then you have to give equal importance to all of this. What the three things we spoke about? One is bias, the other one is stability, the other one is linearity. So the solution, ultimately the solution to the bias is calibrating your measuring instrument, right? And the calibrating frequency, if you want to understand the calibrating frequency, then you should have an idea about the stability. Do you understand?
Right.
If the equipment is going to be stable for 6 months, then what do? We calibrate it once in 6 months. If the equipment is found to be stable for just 3 months' time, then we calibrate once in 3 months, because after 3 months it becomes dynamic. Bias, will start fluctuating in a very random manner, which we have no clue. So we immediately go for the calibration. Similarly, based on the linearity, always for the range of the reading we are going to take, we need to know whether the bias is constant throughout the entire range. Yes, sir.
There is a raise by Vanit Srivatsa, Rajesh Kumar, please.
Yeah, my question is, can we say that this bias exercise can be applied to the data type continuous, where we have the unit of measure, or there is no specific rule for this?
Yeah, bias is
Yeah.
continuous data.
Okay.
Bias is for continuous measure characteristics.
Okay, noted. Thank you.
Rajesh Kumar, yours?
So, see, we're trying to find out stability overall, right?
Stability,
yeah,
over
yeah.
a time period. That's over a
That's-
time period. No?
Yeah, over the
Good.
time period, that's the achieving point.
So
To
what
have a
is the
stability.
solution for this, Rajesh Kumar? The solution for this is calibration chart taken over a time. You can see in all the laboratories, no, they will see the calibrate, they will do the calibration for the gauges every 1 year or 2 years. Okay.
Right. So my question is,
Yeah.
so to have, let's say last 3 months, we are trying to do some analysis, right?
Yeah.
Based on some inputs, but there could be some variations because of, as you again said, like it's all dynamic environment. So there could be some chances that somewhere there was some additional kind of, as you said, like electricity, right? Or overall in the factory, maybe some new equipment is bought in between these 2 months, 3 months. So you will never, I personally feel that it'll take longer time to get stability, depending on what all equipments maybe are implemented, or because of various purposes, seasonal purposes, or business wise, or marketing wise, or something in that way. So how do we come to one point saying that, today we are stable? How do we say that? I mean, it's just a general question I have, nothing to relate with
Correct,
this, but in general,
Understand.
I'm thinking.
Yeah, you want to know whether your measurement system remains stable or not. Correct?
When
Then what
will
we
it
need to
remain?
do?
Right, sir. Right, sir.
Yeah, then what we need to do is, we should periodically we should use our measuring instrument, collect data, and then plot it in a control chart. You understand?
Okay, but right, but then you also said that, for example, Dr. Naveen, he was saying like, do we take, or I don't remember the name, but someone said like every day we take the count around 11 a.m. or 11 p.m., something like that. Even that will not work out, because maybe that time the production was down, and maybe other time it is on. The new machine or new plant is brought in.
See, if you have a doubt about stability of the equipment, then you must start monitoring it. Clear? You have a doubt about stability of the equipment, then you must start monitoring it. Am I correct?
Right, sir.
What do we
You have to-
mean by monitoring? Every day, I pick up my caliper or dial gauge or any measuring instrument. I have a masterpiece this side. Masterpiece means I know its value, isn't it?
Right. Which is stable and working.
Masterpiece is 25.4. I measure this. Today it is giving me 25.6. Now how much is the bias? 0.2.
0.2. Sorry.
This 0.2, I will plot it in a control chart. If
Okay.
every day it is 0.2, my equipment is stable. One day what happened? I came to your lab. I used your dial gauge and completely dropped it onto the floor. I did not inform you. I simply packed it and kept it. Right? I mishandled the gauge and then I kept it. And tomorrow you are coming for the checking. And now you measure the standard. Standard is 25.4. Will this gauge now give 25.6?
No.
I did not
Chances
get.
are-
It might give something 27.8 or something. The bias which was normally 0.2 is now 2.5. That
Right.
means your gauge is now under trouble. You can understand. But this is a special cause, what I explained. Someone dropping the gauge completely on the floor is a special case. Even if you use it correctly, still the bias can increase. If the bias behaves dynamically, then it is difficult for you to apply your calibration formula.
Exactly.
So you need to study how long the equipment remains stable. And now you realize after 3 months of usage, the equipment started behaving dynamically. Now you will take a decision. Let us calibrate this gauge once in 3 months.
Mhm.
Right?
So there will be
Let us
some
calibrate.
end,
Yeah.
right, sir. So there will be some endpoint, right? We'll have to decide on how
Yeah.
when this
See, your company has some idea for calibration. They don't calibrate all the equipment at a time. Some equipments, like already I told you, yearly once only they calibrate. Because with the past knowledge is available, isn't it? The equipment, when it is used in this manner, proper maintenance and all those things, you take care. And that if your people properly use the instrument, and it is estimated that it will remain stable at least for a year. So after 1 year, you calibrate it. But for certain measuring instrument, you calibrate more frequently. Even though you keep the equipment in an air-conditioned environment, even though your people are using your instrument very carefully, then also it must be calibrated in once in 3 months. You have come across such scenario, isn't it?
yeah, depreciation would be there.
Yeah.
Depreciation would be also.
This is
Wear and
based
tear
on
is a-
this is based on how a particular measuring instrument behaves over time. The behavior means the bias, how the bias is changing over time. That will throw light on stability. If the stability is, ensured for, let's say, for a particular period of 3 months, then once in 3 months, we will calibrate. After 3 months, there is no guarantee that your readings are stable.
Right, exactly. That is where I was, my doubt was.
Exactly.
Yeah.
If you're
Initially,
not
when you buy
happy with
the equipment,
yeah,
initially when you buy the equipment, you feel everything is going good and you take some measures. But after a few months, you would start noticing that some production or something is causing some kind of impact. And you don't know which one is involved to do that. Yeah.
correct. So ultimately, the
Thank you, sir.
solution to the bias problem is calibration, proper maintenance of the equipment, proper usage of the equipment. These things will ensure the bias is minimal or eliminated. And
Great, sir.
if needed, the calibration frequency can also be increased. If you are still not happy, then you have to increase the calibration frequency. But in all scenario, we have to take care of the maintenance and proper usage of the equipment, and how to use the instrument, how to measure, and all those things. People have to follow very correctly, and then the bias can be minimum. So
Okay, sir.
we understood about
Thank you, sir.
stability. Similarly, linearity is a little confusing topic. We'll take it up at a later stage. Right?
Thank
So I
you,
think-
sir. Thank you.
Yeah. I think we should stop here for your lunch and then we'll come back by 2:15. Is that all right, all of you? How you
Yes.
can
Yes,
bias?
yes.
What is very important? You need a standard piece, right? You need a
Correct.
masterpiece,
Masterpiece.
a reference value. I mean, a reference piece. And with respect to the reference piece, you ask the appraiser to measure it. Generally, we say measurement system analysis because inside the measurement system, we not only have the measuring equipment, we have the part and the characteristics that is to be measured. We have the operator or the appraiser. We have the instruction that is given to the operator and the environment. So there are 5 different elements inside your measurement system. One is the measuring instrument. The other one is the operator. The third one is the operational definition. The fourth one is the part and the characteristics that you are measuring. And fifth one is the environment. All the 5 together is known as measurement system. If there is a bias, if there is an error, it can be due to any of these elements. You can't straight away blame the measuring instrument or you can't straight away blame the operator. It can be any of the 5, isn't it? So ultimately, we need to take the right actions so that our equipment can be error-free, our readings can be error-free. And in order to ensure the bias is stable, bias is constant, and bias is minimal or zero, we calibrate the equipment, we calibrate the equipment at frequent, at the appropriate frequency, and we take care of the maintenance of the equipment, and we ensure the equipment is used in a proper manner. All of this put together will minimize your measurement error, right? Particularly bias. Now we are going to move on to another element of measurement error, which is known as precision error. Precision means, the
Correct.
precision, precision error means inconsistency in the reading. But precision is good. We need precision. We want our readings to be consistent. But if there is a problem with the consistency, we call it inconsistency. We call it precision error. And precision error can be of 2 types. One is repeatability error. Another one is reproducibility error. One is repeatability error and reproducibility error. And normally the error depends on one more important characteristics of the measuring instrument, which is known as resolution. Hope all of you know what is resolution. The resolution is nothing but the least count.
Least count.
Which is also nothing but the minimum signal to which your measuring instrument can respond. The minimum signal to which the measuring instrument can respond. For example, let us all take a measuring instrument. We all have the mobile phone. We all have the stopwatch. Can you all please open the stopwatch in your smartphone? Let us try to use that stopwatch as a measuring instrument. Please open the stopwatch. It will look like this.
Yes, done.
Yeah.
Now, please tell me what is the resolution of your stopwatch in your hand right now. It's a digital
000.
stopwatch.
000.
000. That means it can respond. The least count is 0. Cannot be 0. Least count cannot be 0. What is the least count?
It may be a microsecond, sir.
Okay. So micro means 10 to the power of
It is
-6.
1,000, one of the
3.
1,000.
3.
10 power
10 to the
6.
power.
10 to the power of 3 or -3 or -6.
10 to the power of -3, sir.
-6 micro.
What is milli then? What is milli then?
-3
Milli is -3. Micro is
-6.
-6.
nano is -9, right? So is it really taking you to -6? It's not microsecond.
It is
1 second is divided into 100 parts. That means it is 10 to the power of -2 seconds.
Yes.
That means it is 0.01 second. You can safely say 0.01 second. That's all. 0.01 second is the safe. If you want to, call it very specifically, then it is centisecond, 1 centisecond. Right? So now the measuring instrument, what you have is a stopwatch, digital stopwatch, and the least count is 0.01 second. All of you, do you understand? It is 0.01 second. Correct?
Correct.
Right. Now we are going to understand the repeatability error and reproducibility error. What is repeatability error? If there is an inconsistency within a single appraiser while measuring the same characteristics multiple times, the error committed is known as repeatability error. All of you understand what is repeatability error?
Yeah.
Yes.
If I involve multiple appraiser and all of them measuring the same thing, but coming out with different observation, the error committed is known as reproducibility error.
Reproducibility.
So ultimately, the sum of repeatability error and reproducibility error together is known as precision error. The repeatability error and the reproducibility error, when I combine them, that is known as precision error. Always the precision error is compared against the tolerance. The precision error is compared against the tolerance, nothing but the working range of the measuring instrument. I mean, the range with which you want to use the measuring instrument. Let's say you want to work between 100 plus or minus 0.5. 100 plus or minus 0.5 means 100.5, 99.5. The difference is just 1 mm. 0.5 right side, 0.5 this side, 1 mm. So 1 mm is the working range. With respect to the 1 mm, how much is the repeatability and reproducibility error? That is precision error. And industry standard says it should be less than 10%. That means if you have 1 mm as the working range, then the measurement error should be less than 0.1 mm. Less than 0.1 mm. Otherwise, the chances of rejecting a good product and chances of accepting a bad product will be very, very high. If you accept a bad product, that is known as type 2 error. If you reject a good product, that is known as type 1 error. So if you type 1 error is dangerous to manufacturer because you are producing good product and your own quality inspector rejecting it. Same side code. That no company would like. So no, your measurement system has to be sound enough. Though industry standard says 10%, it can be lower than 10%. So that major percentage of your good products are accepted in the quality inspection. Similarly, type 2 error, where due to the measurement error, your inspectors are rejecting, accepting a bad product. Accepting a bad product goes to market and customers will be in trouble. So type 2 error is consumer risk, type 1 error is manufacturer risk. We want to limit both of them. That is why measurement error should be less than 10%. At least 90% of your good products are accepted as good and 90% of your bad products are rejected as bad correctly. The risk is limited to only 10%. But the risk is only, at the rejection area. Where do we reject our product? When it crosses the specification limit. So 10% plus or minus to the right of specification limit and to the left of the specification limit will be always the risky zone. Hope all of you understand, right? This is called zone of non-conformance. The zone of non-conformance is what we are trying to quantify by GAGE R&R. You can keep this zone more than 10% or less than 10%, which is good. Less than 10% is good. After non-conformance zone as less than 10%, also ensure your process never go to that region. For that, that is why we keep higher capability. All right. So the repeatability error and reproducibility error, we will try to understand with some, first of all, some live exercise. So let us collect some data and we will try to understand.
Yes.
Yeah. So now we collected data for 3 songs. Normally in a GAGE R&R study, we must have at least 10 different parts. But here, how many parts we have selected? We have selected only 3.
3.
Normally for a gauge R&R study, you must select 10 parts and that 10 parts should cover up the entire range of your tolerance. 10 should cover the entire range of your tolerance, which means from lower spec to upper spec, you should cover the entire range, right? Now coming to our example. Now the third time also, whatever variation you see, that is called again reproducibility error. First time also there is a reproducibility issue. Second time also, third time also. Now, if I say, suppose, see, though I have not made it in that manner, let us assume that all the 3 songs that I played were of same duration. Do you understand?
Yes.
I can always do it that way, isn't it? I can, if I pre-select the song and and fix the duration, and I can play 3 different songs, but still you might think that they are different songs, but the characteristics is same. So assuming all the 3 songs are of same duration. Now look at the reading of first appraiser Maruti Sharma. Are you able to notice any variation across the first row?
Yes.
Yeah, 75.98 and then 79.98 and then 82.21. Actually, it is the same songs. I mean, same duration. All the 3 readings would have been same.
Right.
But it's not happening. That means there is an error within the reading produced by Maruti. What is this error known as?
Repeatability.
Repeat.
This is repeatability error.
Repeatability.
The error within single appraiser is repeatability error. The error with the multiple appraiser is reproducibility error. You can calculate repeatability error operator wise. RK sir, can you calculate the range for Maruti's reading?
Range
the
for
range?
Maruti.
Yeah, maybe in one column, somewhere here, yes. The range, the maximum of the 3 minus minimum of the 3. Maximum of the 3 values minus minimum of the 3 values. And you can drag it down for all the operator. Now this range is an indicator of the repeatability error by each appraiser. Am I right?
Yes.
Now who has committed more repeatability error?
139.6, row number 6.
Roll number 6. You know why that much error came?
No.
It could be problem with instrument, or it could be problem with operator, or it could be problem with the instruction. What can be the problem here? Too much error, isn't it?
Yeah.
Yes. Operation error.
Operational definition. We understood in a particular manner, but then it is collected in a different manner. So that's why operational definition also have to be very careful. One of the important point is all the readings should be in the same unit of measurement. That 119 is not in seconds. Not 119, or what is that? Yeah, 119. That is not in seconds. That is 1 minute 19 seconds. Am I correct?
Yes.
So we have to change it to 89, I believe. Sorry, 89 or
79.
79.
Sir, make it 79, sir.
Now the thing is, now you can do an YY analysis. Why that particular song he has given so much time? He must have been involved so much with the too much with the heroine there, maybe. Or he might have liked the song lyrics very much. Or he might have slept off.
Subject deviation.
Yeah, we can find out all these things and then take corrective measures.
Yeah.
Right.
Sir, you make it 79 there. Okay, sir, you type 79.
79.
Yeah, make it at 79. Okay.
Now
So now we have some realistic measure of the repeatability. Now, even then, who is contributing to more repeatability error?
Number 6.
Number 6.
Again, same, right? Roll number 6, and then roll number 9, and then we have roll number 4. So this is how we are looking at 2 things. Please understand. And one thing is we looked at the measure of variation, which is range. Can you also see the average reading for song number 1, average reading for song number 2, and average reading for song number 3? All of you, can you see the average?
Yeah.
The
Yes.
difference in the average is an indicator of the reproducibility error. Can you see that? If
Yeah.
all the three average or same, then reproducibility will be better. But if there is a difference in the average itself, and now maybe we need to calculate actually operator wise, it is calculated in a different manner, song wise. Can you see that? Here it is calculated song wise. Song wise reproducibility is poor. Particularly song number 3, the average seems to be quite different. So now what we understood is, we practically understood how repeatability error populates and how reproducibility error populates, right? And the same thing will populate during your data collection also. All of you agree? You can't say no error when I collect the data. Error will definitely populate. As long as the error is minimal, under control, you don't have to worry. But if it is beyond control, then that can affect your decision making. You will start taking wrong decision, right? Whatever baseline you calculate may not be the actual baseline. So we should not do that mistake. So with that idea, we are going to proceed with the PPT. So RK sir, I'm just stopping the screen share.
Yes.
So now let's see how the calculation will work. With the GAGE R&R. I'll show it with the formula, and then I will also it up. So here is the repeatability definition. So repeatability means it is good. Repeatability error means it is bad. Consistency is good, inconsistency is bad. Repeatability is the consistency of a single appraiser to measure the same part multiple times with the same measurement system. It is related to the standard deviation of the measured value. But what did I calculate? Range. I calculated range, but normally it is calculated by measuring standard deviation. So if the standard deviation is less, repeatability error is less. If standard deviation, repeatability error is more. Reproducibility. For reproducibility, operator wise average. Can you see one black color line? Operator 1 average, operator 2 average, operator 3, operator 4, 5, 6, 7. If there are 7 operators, there will be 7 averages. If all these averages are same, reproducibility error is 0. If the averages are different, that means there is reproducibility error. That's where the definition is. Reproducibility is the consistency of different appraiser in measuring the same part with the same measurement system. It is related to the standard deviation of the distribution of appraiser averages. Look here, there is a distribution here. What is center line? The center line is average of the appraiser averages. You are able to understand my language? The center is average of the averages. Then each point here on the curve is a average. It is distribution of appraiser average. Means we are talking about sampling distribution. Am I right?
Yes.
I think we spoke about this in the previous days. Did we speak about population, sample, and sampling?
Yes, sir.
Charter.
We
Yeah.
spoke, right? Yeah. So this is actually a sampling distribution because every point is an average. That the advantage with working with average is you can definitely expect normality. If you plot all the averages, the tendency to exhibit normality is very, very high. It simply depends on your sample size. And this is actually known as central limit theorem. Anyway, no worries. So now this is distribution of averages. Whatever variation you see here, that variation is a measure of reproducibility error. The standard deviation of this distribution is known as standard error. All of you are with me? The previous one, the variation here, the standard deviation is known as standard deviation. That's all. This is standard deviation of the sample data. But here, whatever standard deviation you are seeing here, what is the name of it?
Reproducibility.
Standard error.
This is actually we are trying to measure reproducibility error, but this deviation is known as standard error of mean. Because it is an average, am I right?
Yeah.
if in your distribution, if every point is an average and you calculate standard deviation of the averages, then it is known as standard error of mean. This is another important statistics. Please note, there are standard deviation gets different name. One is standard deviation of the population. Another one is standard deviation of the sample. Now I am talking about standard error. So by calculating the standard deviation in different manner, we will be able to understand, the different errors. In this case, the standard error helps us to understand the reproducibility error. Now, anyway, we need to combine the repeatability error and reproducibility error. See here. Now, how can I quantify repeatability error? In order to quantify repeatability error, we know that with the help of the data, we can calculate sigma, right? After getting sigma, please multiply by 6. If you multiply by 6, what percentage of the population will be covered? 3 sigma on the right, 3 sigma on the left.
99.99.
If this person is involved in data collection, the maximum error he may bring during data collection is 6 times sigma. Please note, we have still not collected data. We have still not collected data. We did a sample collection. We did a sample study, isn't it? Only for measurement system analysis purpose, we collected some data. With that, we calculated standard deviation. By multiplying the standard deviation by 6, we get an estimate of repeatability error. For every operator, there will be repeatability error. And finally, you need to combine all the repeatability error. The sum of the repeatability error is here. Can you see that, all of you? All right.
Yeah.
Then reproducibility error. For calculating reproducibility error, you need to use the operator's average. Average of the first operator, average of the second operator, etc., etc. And that is reproducibility error. Again, here also we calculate sigma initially. That sigma is nothing but standard error. We multiply that standard error by 6. That will give a quantum of reproducibility error. And then you combine. You have to combine. Now it is known as precision error. So precision error is nothing but sum of the repeatability error and the reproducibility error. This is not algebraic sum. This is statistical sum. Right? This is statistical sum. So now the precision error is compared against the tolerance. Precision error is compared against tolerance. Tolerance is USL minus LSL. Tolerance is USL minus LSL. So precision divided by tolerance to get a ratio. That ratio is known as precision tolerance ratio. That is otherwise known as gauge R&R. That is otherwise known as gauge R&R. Now, the gauge R&R value is available with us. If the gauge R&R value is less than 10%, your measurement system is considered good. If the gauge R&R value is 10 to 30%, measurement system is considered conditionally good, conditionally acceptable. But in any case, if the gauge R&R value is more than 30%, it is unacceptable. All of you understand the gauge R&R guidelines? What is gauge R&R? Precision
Tolerance
ratio.
ratio.
Precision error, repeatability error, plus reproducibility error. And the calculation will go little hectic. You don't worry. Either you use Minitab or you can get a template from RK and that will do the calculation, right? And that will group the data and then calculate standard deviation and apply all of this. And then you get a gauge R&R value. All that you need to do is take decision. If the gauge R&R is less than 10%, the measurement system is really good. You can use it for data collection. 10 to 30%, conditionally acceptable. Conditionally acceptable means it depends on your process capability. If your process capability is too high, then only you can use the second condition. If the process capability is weak, you must definitely stick to the first condition. If the process capability is better, then you can even use the second condition. But in any case, you should not collect data with the measurement error or the gauge R&R value more than 30%. Is it clear to all of you when to use 10%, when to use 10 to 30, when to use more than 30? We never collect data when the measurement error is more than 30%. So now we will do a small exercise in Minitab. And this is a summary of what we have learned so far. Please read and then tell me whether you can understand this correctly. Bias and gauge R&R. Calibration eliminates bias. Increasing calibration frequency improves its stability. Gauge R&R should be less than 10% of the interest zone. Normally, interest zone is USL minus LSL. If USL, LSL are not known to you, like one of our participants was saying, sir, customer tolerance not available. In those cases, you can use process tolerance. In those cases, you can use process tolerance, which is known as steady variation. Which is known as steady variation. But I think tolerance will be available always. Clear, all of you? All this?
One question, sir. Bias, percentage bias and gauge R&R. How can we correlate them?
Bias measures the accuracy.
It is completely different. Okay.
Different. Bias
Okay.
measures accuracy. Gauge
Okay,
R&R
but-
consistency.
Okay. But there also we talk of less than 10% in bias.
Yeah. See, ultimately,
Always.
error should be less than. See, bias can be eliminated. Please understand.
Okay.
Bias can be eliminated. But
Can I
this
come?
gauge, what do you call the consistency error? The gauge R&R cannot be eliminated. Yes, sir. RK, sir.
Please note, bias is one thing which we say that we can be eliminated. Yes or no?
Yes.
We also say that it is different, this is different. But while measuring gauge R&R, the error is included. Whatever error including bias is included there. I'll tell you, for example, instead of the gauge is showing 2 millimeter away, I am reading it as 2 millimeter away. Then what is this? This is not a bias. Be it
Okay.
bias from the instrument or be it bias from the operator. Both are same. Error is error. Yes or no?
Yeah.
So that is included in the gauge R&R. That measures. If there is a mistake, that mistake is measured in gauge R&R. Whatever form it comes. But we are trying to minimize it before it goes. Like it is example, like we are giving a model test, no? What test Gopal Sukumar is giving? Why? So that you score 100%. But still you don't score 100%. Yes or no?
Yes.
That's all. Same thing. Thank you.
Sir, one
Okay.
question.
Yes.
Sir,
Ah,
one
yes.
question, Uttam Shah.
Yeah,
Sir, can we plot the data on bell curve, what we have collected recently, the song data?
Song
Can you-
data. But we can collect, we can plot, yes. We can plot and we can expect the normality. But then we need to have some, sufficient data,
Okay, sir.
right? We can plot actually, nothing wrong. Now I am going to show you in mini tabs.
Just Naveen here, just one quick question, sir. This study variation, under what circumstances we can be using?
Yeah, steady variation. When the tolerance is not known, right? Use steady variation when USL, LSL are unknown. When USL, LSL are unknown, you can go for steady variation.
Before going into the market, you can do it.
Okay.
See, any observed value will have error. Am I right?
Right, sir.
Any observed value will definitely have error. What RK sir was saying, that error is nothing but sum of bias plus precision error. Am I right, sir?
Yeah, repeatability, reproducibility, everything.
Anyone. Either it is repeatability or
And also the error that you have purposely included in the part.
Yeah.
Different sizes. That means.
Yeah, that is called process variation. That is called process variation, right? So any observed value will have the measurement error. We are talking about measurement error now. That within that measurement error, definitely there will be a component of bias and there will be component of precision error. If you have eliminated the component of bias, then your error will only have the precision error. But if you don't judge on the bias properly, and if you have not eliminated it, then it will be a combination of both. Yes, sir.
I add, sir. It is like a selection of parts is like giving a good answer paper and a bad answer paper to your teacher to test whether the teacher is correcting correctly or not. The teacher should give good marks for the good answer paper and poor marks for the poor answer paper. Yes or no?
Right, sir. Right.
The same way. That's all.
Can we say this bias is towards the human error and gauge R&R is towards the
We
equipment or
don't
the
call it as
instrument?
a human error mainly because all humans are perfect. You don't employ a person who is inexperienced. You don't employ a person for measuring if you do not know how to measure. Yes or no? And you also give a training for the measure for the person. Therefore,
Right.
it is always a gauge error. Right? The repeatability will always be there with person, but the repeatability occurs because of the gauge. Okay. Therefore, we call it as a
that
gauge
means-
error mostly, not
So
the
it is
personal
more
error.
towards the instrument what we are using. Do you mean to say that it is more towards the instrument what we are using?
Yes, yes, more
Okay.
towards more. Very important term.
All
Okay.
right.
Noted, sir.
All right.
Okay.
So now let us take a sample file. Maybe you can also practice. File, open worksheet. File, open worksheet. And then this sample data folder. Look in Minitab sample data
So your
folder.
screen is not shared, sir.
Oh, really?
Huh?
No, it is shared, sir.
Oh,
All of you,
then
can you see my Minitab screen?
Yes, sir. Yes, sir.
maybe I
No, you have to
restart.
change your view. View change it to sharing view. See the view. No, you are right, sir. Gopal Shukmar, you are okay.
Now I have reached.
Shared,
Side
yeah.
by side view. Select side by side view.
So all of you please know, just sharing my screen in Minitab. I want you to go to file and then open worksheet. Then look in sample data folder. Then you type gauge, gauge AIAG.mtw. And then
Rajesh Kumar, is there a question for you?
Yes, I have a question.
Rajesh Kumar. Okay, please continue, sir.
yeah. So we have the data. What do you see in the first column? Part number. Can you see?
Sir,
So how many?
Mahendraj, see what's up. Yeah.
How many parts are here?
1 second, sir.
Yeah, I
Gopal
can see
Shukmar.
the screen. I can see the
Gopal
screen.
Shukmar, 1 second. Rajesh, please.
Yes, sir.
I called you.
Yes, I said yes.
I called you, Rajesh.
Okay.
Audible or
Sir, if you have a question, you'll have to come out and speak. No, otherwise, how will we know?
yes, I am speaking.
Yeah,
Yeah,
we are
you
not
are
able to
raising
hear
hand.
anything.
You are raising hand.
Yes, I raised my hand and I was trying to speak out with my
Yeah,
question.
speak out, sir.
We are hearing you. Yeah, please.
Okay, so the question what it was, see, we happened to play 3 videos, right? We got some results out of it.
Yeah.
Each one had a different observation based on their time watch, right? The stopwatch.
Yeah. Yeah.
I
Correct.
tried doing it, but see, these are only the results. But we should actually even consider the actual video time, right? When did it stop?
See, actual video's time is required to calculate bias. But to calculate the gauge R&R, we only require the measured readings. That's all. The observed readings are enough to calculate gauge R&R. We don't require the true value. True value is required only for calculation of bias. But what we are trying to do is a gauge R&R value. And I'm not taking that readings which we collected in the video song, isn't it? Why? Because we have not covered it properly. There has to be at least 10 parts and each song has to be played repeatedly. Then only we will be able to measure the repeatability error and reproducibility error. There has to be replication.
Okay.
Because certain procedures have to be followed. So we only played the song 3 songs and only one each, isn't it? Once each, one time each.
Right.
So that's why we are not using the data. Actually, if we wanted to use that, then you have to play the songs. At least each song must be played 2 times. And then, we need to have 10 songs covering our tolerance. So,
Okay. In short,
Shall I add, sir? Shall I add?
please.
Rajesh Kumar, you will be able to understand this and appreciate more clearly when RK is going to teach you a topic called AAA, Attribute Agreement Analysis, probably by tomorrow. you'll be able to understand much clearly there. All these things will be clarified there. Right? That is called accuracy. When the true value comes into picture, we call it as accuracy. Otherwise, when the true value doesn't play a part, we call it repeatability and reproducibility errors. Right? For the present, this is okay. Tomorrow, you will be able to clearly understand everything. Thank you.
But now see here, we have 10 parts here. That's why I'm just using this data, right? 10 parts and number of operator. What are all the operator available here? Operator A, operator B, and then operator C. Can you see here? Operator A, B, and C. So 3 operators. And moreover, each part by each operator, how many times measured? Can you tell me? Part number 1 measured by operator A, how many times?
3 times.
3
Three
times.
times.
3 times.
Replication. This is called replication. If you don't replicate, there is no scope, there is no possibility to measure the repeatability error. If there is no replication done, then repeatability error cannot be quantified. So that is the reason why each part is measured by each operator 3 times. Now 10 parts, 3 operators, each part measured 3 times. 10 into 3 into 3. Totally how much?
90.
90.
So 90 readings are required, Rajesh. That is, then only we can use the data for GAGE R&R calculation. Do you understand? Can you see 90 readings here? So similarly, in your GAGE R&R study also, you need to have 10 parts and operators, maybe 3 operators, and replication is minimum 2. You can go for 3 also. Now let us analyze and try to quantify the GAGE R&R value. For that purpose, go to stat, go to quality tools, come to GAGE study, and then after coming to GAGE study, choose GAGE R&R study crossed. You have 2 options, crossed, another one is nested. Most of the time, the same part will be measured by all the operator. Am I right? Same part will be measured by all the operator. Do you get my point here? How many parts I have selected? All of you, are you with me? Are you able to follow me?
Yes, sir.
9
Yes,
parts.
Please answer.
10 parts, sir.
10.
Selected 10 parts. I measure the 10 parts, each part 3 times. Then you also measure the same 10 part. That's why the study is called crossed. That's why the study is called crossed. So I'm going for the crossed. Now part number. In which column you have part number? Column 1. Click and select. In which column you have operator detail? Column 2. Click and
2.
select. In which column you have measurement data?
Column 3.
3. Click and select. Now there are 2 options, ANOVA and X bar R. X bar R is comparatively, easy to understand. ANOVA, we are going to discuss tomorrow. So X bar R method. Now gauge info, you can type gauge info, whatever you want, you can type the gauge name and then the date of the study, 22 July, and then reported by the black belts and any whatever you want to say about your gauge, and you can do that. All this will appear in the report. Okay. Now go here, option. This is very important. Now you see 6. You remember I also told you, you multiply the sigma by 6 so that you get an estimate. That is there. Now you have to give upper spec and lower spec, right? And if you know the upper spec, lower spec, then GAGE R&R will be estimated as a percentage of the tolerance. If you don't give it, GAGE R&R will be estimated as a percentage of study variation, right? We'll see both. So let us assume the difference between upper spec and lower spec as, let's say, some value I'm giving 6. The difference between upper spec and lower spec is 6. I'm giving okay, and I am giving one more okay. That's all. The reports have come. We'll come to these reports. Now let us go here. Look here, GAGE R&R value, how much it is? Can you see GAGE R&R?
30.58.
30.5.
That means
Not
our
acceptable.
measurement system is unacceptable.
Not acceptable.
You
Yes.
should not use this measurement system for data collection. If you use it, and definitely that will lead to wrong decisions, right? And that's the inference here. Now, if you actually look at Minitab report, see here, whatever I typed, that is appearing here. And then there is a first table. You can skip this table. I'll tell you why. Because error can be quantified in terms using range as a measure of variation, using standard deviation as a measure of variation. The third one is variance as a measure of variation. The first one, this is using the variance. For variance, a guideline is different. Second table. This table is based on standard deviation. Here the guideline we discussed. What is the guideline? Gauge R&R less than 10%, good. 10 to 30%, conditionally good. Less than 30%, unacceptable.
Not acceptable.
Now coming down. Now we are reading this. The gauge R&R value is 30.58%. Unacceptable category. But suppose if you don't know the USL and LSL, then you have to use this. Slightly less accurate. See, always when you don't have correct information with you, then you use statistics, where the accuracy will get affected. Now, this is telling that gauge R&R is 26.68. All of you, do you understand the limitation of deciding based on steady variation?
Less
Right?
than 30.
Yeah, less than 30. It says conditionally acceptable, but actually with the specification limit, it says unacceptable. Now the repeatability error is 20.19. Reproducibility error is 22. Which is higher? Repeatability error is higher or reproducibility is higher?
Reproducibility is higher.
Reproducibility is higher. Now you need to work on reducing the reproducibility. Of course, you need to reduce the repeatability also, because there is no much difference. This is 20, that is 22. See here, 20 and 22, when I sum up, it is not coming to 42. Can you see that?
Yes.
That's why I already told you, it's not the algebraic sum of the error. It is statistical sum. So there is little, max there. Always when you are combining standard deviation, you can't combine algebraically. You have to square them. And then you have to add them. And then you have to take the square root. Now your signal is combined. Do you get my point? If there are two standard deviation you want to combine, no, this max works in the background. That's why it is not tallying. Don't worry about it. This is common. It doesn't mean you have done any mistake. No, this is common. This is how it will be. So now let us go to the graph. So all of you can see the graph. The first graph is a bar chart. In the bar chart, there are three colors. The green color is based on variance. We are not going to use it. You know why, isn't it? The guidelines are completely different, so let's not use it. The red one is for steady variation. You can see that, here also written steady variation. The yellow one is based on percentage tolerance. So which color we should see now?
Percentage.
Yellow color.
Yellow color.
Yellow color, because tolerance is known to us. So according to the tolerance, look here, this bar represent the part-to-part variation. Part-to-part variation means the real process variation is appearing here. And here gauge R&R is appearing. Gauge R&R is measurement variation, and this is part-to-part variation. Gauge R&R should be smaller compared to the part-to-part variation. That is the requirement. It should be smaller and it should be less than 10%. That's the requirement. So we understand gauge R&R is more than 30%, and the reproducibility is little taller than repeatability. That is the information you draw here. And similarly, by reading through the graph one by one, you will be able to even find out the root cause. If you want to control the repeatability, you want to control the reproducibility, isn't it? For example, you want to understand the reproducibility. Who is contributing for the reproducibility error? And can you see a graph here in my cursor?
Yeah.
What is this graph called? Do you know the name? This is known as box plot. This is known as box plot. Look here, in the box plot, there is a center line. This line is median. There is also a plus with circle, isn't it? That is nothing but mean. This is median. The center line, the circle is average. The median value for the operator 2, average value for the operator 2. Median value and average value for the operator 3. Now, if we look at whose median, whose average is shifted, is that
C.
is shifted or
C.
shifted or C?
C got
And A also a little bit.
Yeah, if C also aligns with the A and B, reproducibility error will come down. So you have to take action with respect to operator C. Some additional training has to be given. Where exactly he is struggling, you want to understand. Then you can go here. What is this? X bar chart by operator. Can you see here? X bar chart by operator. And now similar, so for the root of reproducibility can be understood here with the box plot. Similarly, for repeatability, you can look at R chart. You can look at R chart. And operator A, operator B, operator C. Operator A measured part number 1. How many times? 3 times.
3 times.
So can you calculate a range using the 3 value?
Yeah.
Yes.
That is this point.
Yeah.
This is the range. First range, second range, there will be 10 range. Similarly, for operator 2, there is 10 range. Operator 3, there is a 10 range. Now tell me, who is struggling to ensure the repeatability? Is it A is struggling, or B is struggling, or C is struggling?
B is struggling.
B is struggling. And so if you probably know, train operator B on how to use the measurement system and how to measure. Probably he can overcome his struggle. If he overcome the struggle, then your repeatability error will go down. Particularly while measuring the part number 4, can you see? He is struggling too much. Part number 4 is struggling too much. Part number 2 also, this is high. So this is how you can actually bring down the repeatability. You can bring down the reproducibility. But then you have to actually be very good at reading the graphs. Clear? I'll show all these graphs in my slide also so that you will be able to better appreciate. So meanwhile, Vineet, you have a question?
Yeah. So here in right hand side where we saw measurement by operator C was struggling, so he was not meeting the expectation. But on the left hand side in our chart, it shows that operator B has some challenges. So how can one graph shows challenge with an operator C, one graph shows challenge with operator B. So how do we read it?
Very good.
Zoom meeting.
See, this graph range chart talks about repeatability. However, this graph box plot talks about reproducibility. So, see, for reproducibility, you don't use all the data point. I only check whether my average and your average are same. Do you get my point?
Okay.
I took 3 reading, but what is my average ultimately? And you took 3 reading. What is your average? And another he took 3 reading. What is his average? The averages are aligning. But within my 3 reading, the difference is more. That will contribute to repeatability error, right? So if you want to understand who is contributing to the repeatability error, see here, you have 2 different error, repeatability error, reproducibility error. Repeatability error contributed by operator 2 or operator B, but reproducibility error contributed by operator C. Ultimately, we need to control both. So what happened? The gauge R&R will come down. As gauge R&R comes down, then it is good to proceed. Now, what I do is I will show my slides. You can see the graphs better and then understand better, and then we can move on to the next module. So give me a minute. I'll just get the appropriate slides. Okay. Any other question also, feel free to ask. Yeah. So I will share my new slides. Hope all of you can see my slides, right?
Yes.
Yeah. See here, this is the first graph. And
Yeah.
we clearly know that we don't require the blue color bar or the red color bar. What we require is yellow color. You know why? Because we have given the tolerance, isn't it? We have given the upper spec and lower spec. So remove the unwanted element. Now you read only this. Now, what do we understand? Which is dominating? Repeatability is dominating or reproducibility is dominating?
Repeatability.
Repeatability. So repeatability error
Repeatability.
is more than the reproducibility error. That's the information you understand here. And one more thing, what do you understand is the gauge R&R value is lesser than the part to part. Part to part variation is the problem we are trying to solve. And gauge R&R value is close to 40%. That's the information you draw here. Now, second graph, R chart. Now tell me, which operator is more repeatable, A or B or C? Who is good in terms of repeatability?
B.
B. B.
B seems to be good.
Yeah.
But of course, all of their range is under control. Can you see that? Everyone's range is under control only.
Yes.
All
Yes.
the range for all the parts are within the control limit. But still, within 1, 2, and 3, you could see that 2's range is very minimal towards the center line. Probably 1 seems to be far away from the center line. Am I right?
Yeah.
If at all you wanted to work on repeatability, probably you need to work with operator 1. Particularly for operator part number 4 and 5, the repeatability values are away from the center line. So, but at the same time, you have to use the graphs and the statistics very carefully. So operator 2 looks to be good, actually better, but still I see some problem here. Can you see all his points going like a flat straight line?
Yes.
So that is quite unusual. That is quite unusual. Say, for example, in an ICU ward, for every patient, there will be a graph,
Right.
ECG graph. So the graph will always, will go up and down. Suppose suddenly if the graph becomes a flat line, what does it mean?
Dead.
He's gone. He's out of the
Dead.
specification.
Patient dead.
Is out of world. Yeah. So something similar to that we are observing here. That means this is also abnormal. Maybe he is under assessment. Someone you are actually doing the
Yeah,
gauge.
supervision.
Yeah, he wanted to be super perfect. We don't want super perfect result. We want reality. That's why when you are conducting the gauge R&R study, it's even important that you don't even let your appraisers know that you are conducting the gauge R&R study. Will you be able to conduct it that manner?
We can conduct.
Yes. We can.
Conduct the gauge R&R study in a way that even the people who collect the data don't even know that they are getting studied. That is called randomness. Everywhere randomness is required. Otherwise, bias will come and play. I doubt operator 2 is biased. Is my doubt genuine?
Yes.
Yes. Yes.
So that's how you should infer this graph. Now another graph, third graph. The graph name is X bar chart by operator. Operator wise X bar chart. Here the expectation here is, you remember I suggested you to select 10 parts. All of you, do you remember? You select 10
Yes.
parts covering the lower spec to upper spec. Now you have to select a certain percentage of the parts close to the center line and certain percentage of the parts close to the specification. Close to the specification means they are bad parts. Close to the center means they are good parts. Am I correct?
Yes.
Now you have to set a ratio. You decide. Let me suggest 60% of the parts are close to the center line. Then 40% of the parts are close to the specification.
Specification.
Out of the 10, 6 are close to center line, 4 are close to specification. Now, if you plot this graph, the 40% of the parts should know, or 40% of the points should come out of the control limit. The expectation here is 40% of the points should come out of the control limit. If that is not happening, it simply means your measurement system is not good at segregating the bad one. Do you understand? Bad should be segregated as bad. So our expectation here is, if the ratio is 40%, 40% of the point should appear outside the control limit. If this is not happening, your measurement system is not good at discriminating between good and bad. Like RK was saying, if you are a teacher, I give 10 test paper. Out of the 10 test paper, 6 papers are good students. 4 paper are bad students. I mean poor students. Now how many test paper you should pass? 6 students should get pass mark from you. And remaining 4 students should get fail mark from you. If you pass all the 10 students, you are not correcting correctly. Am I right?
Yes.
Your measurement system is bad if it doesn't segregate bad as bad. A bad item should get classified as bad. So you are checking the discriminating power of your measurement system in categorizing bad as bad. All of you understand how to use this graph? You can keep the ratio 60-40, 40-60, 50-50. It is in your hand, 70-30. Nobody will have clue about to know what are you doing. All this information should be confidential and should be available only with you. All of you understand?
Yes.
Very good.
Sir, in that case, if you go by that, in the first graph, first sample, 1, 2, 3, 4, 5 are in above 50%, right?
Which one? Which one?
In the previous
Which
slide.
graph?
In the previous slide here, 1, 2, 3, 4, 5 points are above the close to the line, above the line, green line.
Here.
No, previous one.
Operator 2, the middle one, sir. Middle one.
Oh, okay, middle one. Okay, yes, yeah. Tell me, sir. Tell me. What are you saying? In operator 2?
So in that case, 40% is above. Now it is above 40%, right? So in that case, system is.
That 40-30 we are not seeing here. Please understand. Here, the range is plotted. Here, average is plotted. In range chart, we plot the range.
Yeah.
Range is difference between maximum and minimum.
Correct.
But here, average of each part. Each part there are 3 reading. The average, first average, second average, third average, fourth average. Likewise. So
Yeah.
here only 40-60 will appear. Here it is only range. Right? And you can't say good range and bad range. No.
Correct.
Only good parts and bad parts that will appear only in average, not in the range. Good question. Now, what is this graph? The graph is part-wise response. Every part measured by 3 operator, 3 times each. Part number 1 measured by 3 operator, 3 times each. So totally how many readings will come from part number 1? 3
9
operator, 6, 9 reading.
9 readings.
Can you see 9 readings here? Here also 9 reading, here also 9 reading, here also 9 reading. But the point is, all the 9 readings came from the same part. That means part number 6, your team has measured well. Even part number 7, also your team measured well. Can you see that? Part number 7, there is a very good consistency in the measurement. It looks like a pile of coin, isn't it?
Yes.
But in all other areas, you can see the spread. Spread means there is a problem. There is a measurement error. If there is no spread, 0 spread, that's ultimate. Now, which part your team is really struggling to measure out of the 10? Can you tell me which particular part your team is struggling to
10.
measure?
10th part. 10th part.
10.
Part number 10, you
10.
see here.
10.
So much struggle, like one of our appraiser mingling with a particular song, looking at the heroine, same manner. The part number 10, people are struggling. We don't know why it is. Maybe it's a difficult to measure part. So some extra training is required so that they don't struggle, and then we get the desired level of repeatability and reproducibility. So here there is a consistency. Here also there is a consistency. But part number 10, we could see, a higher level of inconsistency. That is the worst. Here also the spread is more. So this is how. So when you control all this spread, you know what will happen? To control all this spread, what will happen?
Process
Your,
will be in control.
yeah, your both repeatability as well as reproducibility will go down. Both forms of error will go down if you make all the readings appear like this. Now this graph I already explained. Now, but this gives a different scenario. Now who is here problematic? A, 1 or 2 or 3?
2.
Who is
3.
problematic here?
3.
3.
2 is problematic, right?
Yeah.
Because 2 is actually trying to pull down the average. Actually, what we expect is the average has to be at the same level with all the 3. If all the 3 average are perfectly aligning horizontal, if all the 3 are perfectly horizontal, then reproducibility error will be minimal. So probably the 2 has to be given some input. But one more thing, see here. Ultimately, it all depends on how you design your GAGE R&R study. And what is this line called? Can you tell me what is this line?
Mean.
Median.
Median.
This line is median. Isn't it? This line
Yes.
is median. You can parse in a way that it is perfectly symmetrical. If it is perfectly symmetrical, mean will be equal to median.
Right.
Isn't it? That's what one property of normal distribution. So if you select parts in a way that parts are selected in a symmetrical manner, then 2 is actually correct.
Right.
Can you see that? Mean and median at the same point.
Yeah.
So ultimately, we want the team to agree with each other. Either 2 must agree with 1 and 3, or 1 and 3 must agree with 2. But who is correct and who is wrong, if you want to understand, you have to be very tactical, right? And now if you choose the parts in a symmetrical order means at equal interval, and from the center to the right, 5 parts. From the center to the left, 5 parts at equal distance. That means 2 is correct. And 1 and 3 must be corrected.
Correct.
So what kind of action we need to take, you will be able to understand. Now, ultimately, this graph is nothing but the third graph. What was the third graph? The X bar chart, not the range chart, average chart. You see, let us go there. Can you see the X bar chart here?
Yes.
1, 2, 3. If you overlap one graph over the other, you will get the last one. Yeah. You see here, one X bar chart is overlapped with other. There are 3 operators. Operator 1 is indicated in blue color. Operator 2 indicated in red color. Operator 3 indicated in green color. What is required is there has to be a perfect overlapping of the graphs, because every point is average of the readings collected from the particular part. For example, part number 10, operator 3, he took 3 parts, three reading. Average of the 3 is indicated here. This is operator 2 average. This is operator 1 average. What is our expectation? For a better reproducibility, all the 3 average should be at the same point, isn't it? And we could see that to somewhat better extent here. Can you see here? The averages are close to each other.
Correct.
Averages are close to each other. But in certain area, the averages are separating. For example, part number 4, operator 1's average is deviating away from others. Do you get some information here? For part number 4, operator 1 is actually pulling down your reproducibility. Similarly, for part number 10 also there is a problem. What is required is all the 3 averages should overlap. If overlapping is not happening, at least the line should go parallel. Each line should go parallel to each other. If they are not even parallel, at least it should not cross the line. See here, can you see the lines crossing here?
Yeah.
So that means either the blue one, the operator 1, or operator 2. I think operator 1 is problematic. Operator 1 is problematic. That means, when I so far I have been measuring in alignment with the procedure, in alignment with the other operator. But while moving from 8 to 9, I could see my average shifting, isn't it? Normally, in the previous reading, you can see the blue one's average is above the remaining two. So here also it has to come above. So that means while measuring the part number 9, something wrong is happening with respect to operator 2. So with these kind of inferences, you can improve your measurement system. So 6 graphs will give you enough light on the root of the measurement error. If you take appropriate action, right actions, gauge R&R will certainly go down below 10%. That's it. Clear, all of you? All of you, do you understand what is gauge R&R study?
Yes.
So how many parts should be selected?
10.
10.
10
10
parts.
parts minimum.
3 operators. Yeah.
Minimum
3
10 parts.
operators.
And
3
these
operators.
10 parts should cover the entire range. You are selecting the 10 parts. You can have a ratio. You can have the symmetry. Whatever property you want to have, you can set it. And accordingly, you can try to find out whether your people are measuring correctly or not. But if you don't have any tactics, any proper arrangements while selecting the parts, then you will also be under confusion like others. But if you choose the parts and carefully mix up the good and bad carefully, and have some idea about how the average will be, then definitely you can read the graphs better. And that's how you can bring down the repeatability error and reproducibility error. And don't worry, conduct the experiment and use Minitab for the analysis. You don't do it manually because there are a lot of calculation involved.
And this 10 parts is always the same dimension parts, right?
Come again?
Always the 10 parts, whatever we select for the experiment, for the analysis, will always be the same dimensional part.
Same
It cannot
specification.
be.
Same specification. Right?
Yeah, means, for example, if I'm measuring the
Same
shaft.
character to be measured.
One
Okay.
second.
Bluetooth mode.
Yeah. Yeah. Vineet, can you repeat your question? 10
Yeah.
parts.
So this 10 parts, what we are selecting for the analysis, that should always be the same part. Means if it is a shaft, then it is D and L, always the same part, or
Okay,
it
sir.
can be a different part as well.
No, see, gauge R&R study we need to do for the product we are actually currently dealing in our project, number 1. Right? And number 2, gauge R&R study must be conducted for the characteristics which we are trying to improve in our project. You get my point?
Okay. Okay.
So that's that way only you can do. There is no point of choosing a product which is not related to our project. So whatever project the product we deal in our project, at the same time the characteristics we measure, for that only we should do the gauge R&R. Yes,
No,
sir.
that is understood. But the selection of the sample of the 10 parts, so it should be the same part, or it can be a different part but same characteristic. Let's say D and E, for example, the diameter and the length of the part.
Can I come?
Yeah,
Nobody-
please.
Yes, sir. Yes, sir.
1 minute. Yeah.
Can I come, sir?
Yes, sir.
Please note, what is that we are doing now? Think, what is that we are doing now? Yeah. Tell me, what is
So
our
here-
aim here?
Aim to assess the gauge R&R.
Aim is not to assess the gauge R&R. Gauge R&R is something which we are getting. Using that, we are gauging something, right?
Yes.
Our aim is to see whether we are using the right measurement system or not.
Okay.
Yes or no?
Okay.
We are finding out whether the measurement system is okay or not. Before going for this, what was the first step in the measure phase? First, what is to be measured, you fix it up, CTQ.
Hmm.
Once you
Okay.
determine CTQ you are measuring, on what that CTQs you are measuring, also you are fixed. If I'm going to measure welding strength is a characteristic I'm going to measure for the failure rejections and whatever be it, right?
Hmm.
And welding strength we are going to measure on a particular T value item or A item or B item. Some model value number will be there. Yes
Yeah.
or no?
Yeah.
Only that particular item we will have to use, and that particular CTQ will have to be measured using that operational definition, that inspector, and things like that. Yes or no?
Okay.
In
Okay.
order to measure the variation, you have to have a welds of different strengths.
Right.
Because what is to be passed and what is not to be passed also should be there. Yes or no?
Okay.
You select the parts in such a way that you have the bad part as well as the good part. What we say decently, diplomatically, is that range of product, range of the what you call measures, right? We call
Okay.
it, you have the product over a covering the range completely, so that your system is able to measure this extreme end as well as that extreme end, which is shown in your normal distribution for that CTQ. Yes or no?
Okay.
Once this is determined, then all you need to do is how many parts are coming, covering the entire range. How many people are there for measuring also,
Yes.
depending upon the number of operators, number of parts, you will have some constants specified in the Bible, right? They will specify some constant. You will have to use that constant. That is based on experience. That also, if you want, we have URLs, a lot of references will be given, but you won't have time for this. But you know that this is called D2 and all, right? Basically, there is a logic. How did we get the 3 sigma? 3 sigma is a process which gives you the entire range produced by the process is covered within plus or minus 3 sigma. Yes or no?
Yeah.
And then who was determining the 3 sigma? How was the sigma calculated? We did not go in for this. Similarly, don't go in for this thing because that will confuse us, but will be clarified if you are willing to spend about 1 month. Right?
Okay.
But it's not required, it should not be done because it will be distracting you. So
Okay.
now you know how to do this measurement system analysis. What we need to do is only find out the sigma gauge R&R. We will give you a template also for that. All
Okay.
you need to do is how many parts, how many persons, and how many times you want to repeat each operator.
Okay.
Once you determine this gauge R&R is less than 10%, you straight away go ahead with the project. Otherwise, change the gauge or train the operator or do something else. Right?
Yeah.
Okay. This is what is the ultimate aim. And then now you measure the performance.
Yeah.
How do you measure the performance? Find out it is same as what we committed in the project charter. In the project charter, we have committed certain things, and the same thing is shown here, and is okay. We have committed the rejections are 1,000 in million, but here after using this measurement system, it is not 1,000, it is only 3 in a million. That means you are already in a 6 sigma project. Why do you go for this project? Yes or no?
Yes.
That is what is the thing. I hope I have made myself clear.
Yeah.
And baseline performance, you measure it in different ways. One is CpCpk, another is Z level. Z level is for both continuous data as well as discrete data. Right? Performance is same metric, but CpCpk for continuous data and rolled through for discrete data.
Yeah.
DPMO for discrete data.
All right. So I think the gauge R&R is understood. So what we do is we'll go for a break.
Yes,
and then
Sarvana,
after-
Tandapani. Yes.
Yes, sir. Yes, sir. I have one doubt there. In this calculation, we put that upper limit and lower limit. I think you mentioned the boundary 6. Without that boundary, we can do, sir.
And that is why we can use the process boundary. It is called
Okay,
self-discipline. If nobody is controlling you, we ourselves put
No,
a
in
limit.
Minitab
That is called
without,
control limit which you are using, and that gauge R&R is called steady variation. Okay.
See, you have to declare specification limit. If you don't declare, then gauge R&R will be calculated based on steady variation.
steady variation. Okay.
Within your data, the maximum will be considered upper limit, the minimum will be considered lower limit.
Okay.
Assuming this, the gauge R&R will be calculated. But it is always good that you declare the specifications so that it will be more realistic.
Okay.
All right.
It is
So
like
what
a-
we do is we'll have a break here for 15 minutes. And then when you come back, maybe one of you can do the gauge R&R analysis in Minitab, right? So please come prepared with the Minitab with you so that I'll just make you do the gauge R&R study yourself, because this calculation, doing it manually, nobody will be doing it manually. So don't try to do it, right? So lot of calculation have to be done. Data has to be arranged in some proper order, and it has to be combined in proper manner. And that will be definitely tedious job. And we can learn it if we need it, but not now, right? Probably separately we can do that. But either you use Minitab or RK can give you a template. Use any one of that. But you should be very good at reading the report and reading the graph and taking action, so that the really gauge R&R value can go below 10%. So we'll break here for 15 minutes, and then 4:10 we'll assemble back. All right. So you can first of all create a gauge R&R study worksheet. So go to
Okay.
stat,
Start.
come to quality tools, then come to gauge study, then go to create gauge R&R study worksheet. Create gauge R&R study worksheet.
Second option, yeah.
Yes.
Okay.
And now it will ask you how many parts. So our idea is minimum 10 parts.
10.
Can you see
10
10?
parts.
Yeah.
Yes,
Yes.
yes.
And the number of operators normally 3, and the selection of the operator, please be random selection. Use random selection, right?
Okay.
And 3, and replication, number of replication can be 2, can be 3.
Okay.
Make it 3. Make it 3.
That is nothing but the trials only, na, sir?
Okay.
Number of trials.
Number
Yeah.
of times
Measurement.
measuring the same
Measure.
part.
Yeah.
And now 10 into 3 into 3, 90. Operator
90.
also you can give. For example, you can give your name Saravanan, you can give Maruti name,
Okay.
and you can give Rajesh name. You will type. First number 1 is Saravanan, and number 2 is Maruti, and number 3 is Rajesh. Similarly, you can change the part name also, but you only change the operator name. Maruti and then Rajesh. Now you give OK. Now Minitab will randomize the thing, everything, and then will suggest you. You see, in this manner only you should conduct the gauge R&R study.
Okay.
So what is the first experiment? Can you see? First experiment will be
Part.
Saravanan will measure part number 7.
Yes.
What is the next experiment? Saravanan will measure part number 5.
Part number 5.
5.
Why are we doing in this manner? This is called randomization. If you don't
Yes.
randomize, bias will come and play. Right? So in order to
Yes.
minimize the bias, we randomize. So I think what happened to that sheet? I think
1 minute.
no. You just below window,
Okay.
mala top. Next to tools, there is window, right?
Yes. Here.
No.
No,
here.
at the top.
At the top.
Where you selected stat on that right hand
Yeah.
side. Stat.
Just below that window option, there is a blue color button. You click that blue color button.
1 minute.
I think that will show the worksheets.
Yeah, just go up.
This one?
Further, go up.
One from file, you come to window. File, edit, data, come up to window.
Right hand side.
Window.
Yeah.
Okay. Yes.
That blue color, wait. That just below window, there is a blue color button. You click outside. Yeah. Blue color.
Yeah.
This
click
one?
that.
Yeah.
Now you see 2 worksheets on the left side. The second one has to be opened. Yeah. You open the second.
Yes.
Yeah. This is what we want. So now in this order, you have to conduct the experiment. And now you will have, once you have 90 data, you can
Yes.
analyze.
Okay.
And in order to analyze, let us take a sample data here. Go to file,
Okay.
go to open worksheet,
Okay.
and click the looking Minitab sample data folder. Click it once. Bottom left, green color icon. Bottom left.
Open
Come down,
left.
left side, green color
Yes,
icon.
yes,
Yeah, click that.
yes.
And in the file name, you type gauge AIAG.mtw. GAGE, gauge. Gauge
One.
AIAG, second one. Gauge AIAG.mtw. Second one.
TW.
Yeah, click.
Yes.
Open. Open. Okay. Yeah, bring it up. Yeah. So now you have some data. Now we need to analyze the data, right? Now same situation.
Yes.
10 parts, 3 operator, 3 replication, 90 readings. Now how will you
Okay.
analyze? Go to stat. Quality tools. Go to stat.
Third, fourth, fifth
Stat.
one.
Third,
Quality tools.
quality tools.
Come to gauge study.
Study.
Come to gauge study crossed. You know why it is crossed? Same parts are used to
Yes.
be all operator. Crossed. Come down.
Yes. This one.
Click. Now
And
part number,
yes.
you give column number 1.
Or one.
No. You click and select from the left side.
C1.
Oh,
No, you can't type. You You remove.
okay.
Click and select. Left side, you click and select. No. Within that window itself, C1.
Okay.
Can you see C1? Yeah. Click,
Okay.
select left side.
Double click.
Within the
selected.
window,
Bottom,
there is a
bottom.
select bottom. There is a select button. Yeah.
Yes.
Yes.
So similarly, do it for operator. Click select.
Okay.
Then for measurement data, click select. And
Okay.
change the method of analysis to X bar and R. Left
X
side.
bar and R.
Center. Yeah. Now
Now
go to
what?
options. Wait. Go to options.
Options. Yes. Lower
And
limit, upper.
upper spec minus lower spec. Give the specification,
Yes.
then only yellow bar will appear. And click this, select the second option. Upper spec minus lower spec.
Option.
Click
Yes.
option. And
Okay.
here the value is required. You type the value. I gave 6. You give 12.
Yes.
You give 12.
Oh.
You type 12. The difference
Okay.
only you are giving. Now you give OK. And one more time OK. Now the graph, you know, you are an expert in reading the graph.
Yes.
You can understand what the graph is telling, and go to the session window. You bring that graph down. Just push it down, and then yeah, there only gauge R&R for measurement. Yeah, you
Yes.
slightly maximize that window. Yeah. Now there are two column. I mean 2 table available, right? Come down.
Yes.
You have to leave the first table. Don't read the first table.
Yes.
Yes.
Read the second one. Come to the second one, because our guideline is based on the second table.
It's
Now look at the gauge
15%.
R&R.
15%.
15.
15.29.
Earlier it was showing 30.
30.
30.
Yes.
Yes.
It is showing only 15 because we increase the tolerance.
Correct.
Yes. Double
Yeah.
the
Tolerance
tolerance.
is more, the measurement system holds good.
Okay.
That's
Right.
why the conditionally acceptable condition also. When your process is highly capable, then 10 to 13% also acceptable. But when
Okay.
you have a problem with objection with the capability, you should strictly stick to the first rule. The gauge R&R should be less than 10%. So now
Okay.
you understand it is 15% with respect to the tolerance, but 26% with respect to the steady variation.
Study.
Yeah.
So you know the limitation of reading from the steady variation. If the tolerance is clear, then you get a realistic estimate of the error as a percentage of the tolerance. And again, this falls into the category of conditionally acceptable. And graph
Okay.
also you can read, and then you can take decision. Hope now you are able to analyze with the Minitab. All of you, all others also.
Yes.
Yes, sir.
Yes, sir.
The worksheet will guide you on how to conduct the study in your workplace. Once the study is conducted, data is collected, then put it in Minitab and then analyze. That's all. You want to try once again? Now I think you can do it faster. One more time, you analyze the same data. Saravanan,
Yes, yes, sir.
some practice will make you perfect, right? All of you.
Yes.
All right, you're done.
1 minute, sir.
Yeah. You need left side worksheet, you have to open first of all. No,
Okay.
you are- okay, opening fresh.
Yes.
No, click that icon, green icon first.
Yeah. Then I come. And
Then you type the
GAGE.
file name, GAGE AIAG. These are inbuilt files,
Okay.
and just for practice purpose, you can use. Now the
Okay.
sheet has come.
Yes.
Now you can analyze this.
Again, I will go for 5.
For analysis, you go to stat.
Start. Yes. Start. Quantitatives. And
GAGE R&R,
steady. GAGE
GAGE
steady.
R&R
And
crashed.
first. Okay. Now what the measurement already selected.
Already selected.
Yes,
Already
selected.
previous
So,
Excel file it is. Okay. Anyway,
yeah.
same result will come.
Uh,
Double click left side. Yeah. Otherwise, yeah. No, you have to. Expire R only.
select
You put your cursor in part number.
part number. Yeah.
You put and now select.
Then select. Select. Measurement. Select. Then I go for
Option.
Option.
USL LSL declaration. It can remain as 12 or you can
Six.
change it.
Can this
Put
one
14 now.
make it 5?
Okay.
5.
Okay, 5. Okay, right.
That means
Okay.
now our GAGE R&R will be higher now. Okay, give
Yes.
okay.
Then okay. This.
So this
and,
is for
Gone beyond. Is above 30%, it seems.
yeah. It has come. Come down.
30.
Further down.
Yeah.
Further down.
Further down.
Yes.
Yes.
36%.
36%. Failed again.
Yes.
So now this analysis you can post it in LinkedIn. People come to
Okay.
know that you have got some new skill now, right? GAGE R&R stuff, right? And you write whatever you know about just 2-3 lines very carefully, right?
Okay.
And post it, and that will bring a good visibility to your new skill. All right, you can stop sharing.
So, and one more thing, this one, how to clear this one? While
Which one you want to clear?
after okay, I will do this as a sample. I have to save this one. How to save? Same.
You want to save?
Okay. Yes.
Then in the file option, there is go to file. There is a save option. You can
Okay,
save,
save
project.
project.
Means you save project means all the analysis will be available.
Okay.
Save worksheet means data alone will be available.
Okay.
Right? Save project as. If you give save project as, you go for save project as.
Yes.
Give a name. Next time when you open, it will open with the graphs, everything.
Okay.
Save worksheet means only data will be saved.
Okay.
You should remember the name and then you can open it. Clear?
Okay. Yes.
All right. So we move on to the next part. You can stop sharing.
Okay.
You know what is the next part? Now the next part is measuring the baseline. So measuring the baseline, we already learned DPMO. I'm not going to repeat. I gave an Excel calculator also. I hope all of you are also using the Excel. See, any tool or template or Minitab software, whatever we teach, unless and until you practice, you will not feel comfortable. You will feel isolated, no? If you don't really practice using that, at least some example case. All right. So now baseline performance, yield, DPMO, and CpCpk. There are different measures of baseline performance. We call it process capability. Yield. There are 3 types of yield: traditional yield, first pass yield, and throughput yield. And then DPMO, we already did GEMS experiment, and CP and CpK. There are a few others which we will be seeing in the advanced level. Now, what is traditional yield? What is the output and input ratio? Let's say you produced 100 parts. Out of 100 parts, 90 parts are accepted. 10 parts are rejected. Now, what is your yield? 90%. All of you understand this, the yield calculation? Let's say 90 people write the exam. Sorry, 100 people write the exam and 90 people pass the exam. So what is the pass percentage? 90%.
90%.
That is called yield, traditional yield. You can apply this thinking to calculate the performance. And now this is a banking transaction, like a Google Pay or Phone Pay or whatever. Now there are 100 transactions happening. And out of the 100 transaction, 10 transaction got failed. You know what is a failed transaction? The transaction is unsuccessful. So how many transactions are really successful? 90. Now how much what will be the yield here?
90%.
90%.
Will you be able to calculate yield in this manner, be it manufacturing or be it non-manufacturing? Let us say 100 tickets are raised. Customer raises a complaint. So 100 ticket numbers are generated. And 90% of the out of the 100 tickets, 85 tickets are resolved within the timeline. But remaining 15% of the 15 tickets, you are not able to resolve. The cases are still pending. That means what is the yield here? 85%.
85%.
Very simple. Output divided by input. That is traditional yield. Hope all of you will be able to calculate the traditional yield.
Yes.
Process. Very, very simple. But the problem with the yield is, traditional yield is, it doesn't take into account the rework. We discussed 100 people wrote the exam and 90 people passed the exam. Actually, when I get into the details, I realize 10 people have passed the exam by writing the exam in the second attempt. When you asked Prabhakar, hey, what is the passing rate? What is the number he told? 100%, right?
Yeah.
100% pass rate. Don't worry. That is a traditional yield, isn't it? Of course, everybody passed the exam. That's not a problem. So that's a traditional yield. But what happened actually? Let's say 10 people, wrote the exam 2 times. That means in the first time, how many people have passed? Only 90 people. Only after considering the re-exam, the yield is 100%. Same manner. When you say, sir, our yield is 90%, you need to immediately ask another question. Is there any rework happened or not? If no rework happened, then whatever yield that is communicated, that is the first pass yield. But if there is a rework, you must subtract. You must subtract. Let's see an example. See here, there is 100 transaction. Out of the 100 transaction, 30 transaction got delayed. You know what is a delayed transaction, right? The transaction is successful, but consuming a lot of time. The transaction is initiated today, but it has become successful only tomorrow, right? And in spite of those 30 delayed transaction, 10 transaction got failed. Now, what is your yield?
First pass yield is 60%.
The traditional yield will say 90%. But first pass yield, first time, how many transactions are successful? Only 60%.
60%.
Not as 90%, it's actually only 60%. Your perception will change if you change the tool, if you change the way you measure your baseline. So a lot of rework will be happening in our workplace. Normally, we don't visualize it. We think that rework is also good. Rework comes under cost of poor quality.
Correct.
Should also be reduced, right? So the better metric is first pass yield and not the traditional yield. Hope all of you understand the difference, right? So this is first pass yield. Sometimes it is called first time yield. Both are same. Now the third one, rolled throughput yield. Suppose if the output of a process becomes the input for the next process, and the process are connected in sequence. Then you need to use this tool known as rolled throughput yield. See here, there is a first process P1 in which the first pass yield is 90% and the output goes to second process. Here the first pass yield is 80% and the output of the second process becomes input for the third process. There the yield is only 70%. Now, can you make a guess? What will be the final output here?
Multiplication of all three.
70%.
It can't be 70%.
Oh, it is 50% only, sir. The multiplication of 3.
Yeah, we need to multiply all the three. Because here you get 10 people getting dropped. Let's say 100 people join the course. And first level, second level, third level. You have to, one has to go through 3 levels to get a certificate. Now, first level, how many people got dropped? 10
90.
people. 90 people pass and 10 people fail. Now the 90 only will go to the second level. Now 80% of the 90 pass. What is 80% of the 90?
Mm-hmm. So the 8, 9,
72.
72.
72.
Graduate to the third level. Now
7
third,
of it, 56.
56.
third level is little tough. Success rate is only 70%. So 70% of 72 is only 50. So this can be calculated simply by multiplying all the 3 percentages. While multiplying, use the numbers in this manner. 0.9 multiplied by 0.8 multiplied by 0.7. All of you are with me how to calculate the traditional yield, first pass yield and rolled throughput yield. Please confirm. All of you?
Yes, sir.
Very good. So I want to give you a small task now. And you all have to work out. Please note down, I will give the problem in the oral instruction. Imagine there is a tire inflation process. You all know what is tire inflation process, right? So you are filling the air. So there are 360 tires you are inflating. And then every tire is inspected for the pressure. After inspection, 354 tires are found to be accepted for fitment. There is no leakage or nothing. So 354 accepted. 6 tires manufactured are found to be defectives. You all know the meaning of defectives. They are no rejected. Over and above, 84 tires got reworked. This is the scenario. Now I want you to calculate both traditional yield as well as the first pass yield and tell me the number. I am also calculating parallelly. Let's see who can calculate fast and who can calculate correct. 360 tires, 354 accepted. So what is the first pass yield? You can put it in the chat box. Let me see.
76.2.
First pass yield is
76.2%.
traditional yield. First step.
76.67. First pass yield.
Okay. Traditional yield. Please put both the value. Traditional yield. And then minus 6 minus 84, 270 divided by 360. So what is the first pass yield, sir?
360 minus 90.
354 minus
360 tires, 6 tires got rejected. So 354. Within the
minus
354, how many got reworked?
84.
84.
So you must subtract. So only 270 tires passed through in the first run.
75%, sir.
75%.
75%.
76.2. 76.2.
All of you have understood what is first pass yield and what is traditional yield. Clear, all of you?
It will be just for clarification. It will be 354 Minus 84 divided by 354, right? Or 360.
No,
minus
360,
360. Because
360 minus 90.
360 tires.
Okay, but eventually it is 354 what we tested, right? So why?
No,
why
accepted.
You produce,
Yes, sir.
see, you produced 360 for your company, you produced
Okay.
360. 6 got rejected.
Okay.
And within the 354, 84
Again, 84 were revoked.
were reworked.
270.
It means your first pass yield is 75%.
75%.
66 minus 84,
84.
360.
Okay, noted, sir.
If you don't show that 6, put 354 in the denominator, you are hiding in the information to your management. Isn't it? So if you don't show the rework, that also hiding. But many a times we don't show rework, isn't it? We simply convince our boss by showing the traditional yield. But which is better, which is required? First pass yield is required. All of you are with me? Now, will you be able to apply this tool in your workplace?
Yes.
Yes.
Yes. Yes.
You people to give some example of application in your field. You can even WhatsApp me, or you can put it in the graph. I mean, put it in the WhatsApp group. Like I really appreciate the way you all participated last Thursday. Like all of you came up with the project charter. Now many the other participants would have got a wonderful idea how the projects will go on in different domains. So same manner for every tool, try to apply it, use it. Either you put it in our WhatsApp group or you put it in a LinkedIn. Nothing wrong. Post it. And you can tag all of us. You can tag all of us. So we definitely know that will add on to our knowledge. People will come to know how Pareto is used in the software industry, how Pareto used in medical industry, how Pareto is used in the supply chain, isn't it? So you try that. Then the tool, sometimes the tool might be easier, but even then if you connect it with an example, then everyone will be very, very clear. Now look here, DPMO. Already we used DPMO with the GEMS exercise.
Right.
That time itself, you all told me, yes, sir, we are ready to calculate the DPMO on Sigma level for our product also. Now there is one more example. Here the example is a Google form. Each one of you are filling a Google form every day, right? At the end of the training, and there is a feedback form you are filling up. Please do fill the feedback form every day. That will be very good input to us. And now imagine there is a feedback form or a Google form in which there are 10 fields available. One field is collecting your name, other field is collecting your date of birth, other field is collecting, your what do you call your company name, and another field is collecting your salary. So 10 field. You can fill up all 10 fields correctly, or at the maximum, you can fill up all 10 fields wrongly. Am I right?
Yes.
So what is the opportunity, number of opportunity for failure here or opportunity for error here? 10.
10.
10 into 15.
10 here. So for the Google form, we are trying to calculate DPMO. So 10 is the opportunity for defect or opportunity for error. Imagine 15 people are filling up the form. So what will be the total maximum number of defects they can make? 15 into
10
10.
into 15. Yeah.
150.
150.
10.
Total number of opportunities for error is 150. After they all submit the form, there are 22 defects we could see in the report. There are 22 defects we could see. Now I want you to calculate defects per opportunity. Total opportunity is 150 and number of defects observed is 22.
22.
2 upon 150 will be 0.146.
0.146. Yes.
What is this 0.146? DPO.
DPO, defects for opportunity.
So once DPO is known, DPMO can be calculated.
Yes.
Multiply by 10 to the
10x.
power of 6. Because it is million, right? 10 to the power of 6. So 1,46,000 is the DPMO. If you put this 1,46,000 into the Sigma level calculator, that will give you Sigma level, isn't it?
Yes.
Because DPMO conversion to Sigma level, that is formula is available. You can do that. Now please confirm, will you be able to calculate DPMO in your workplace? One example, will you be able to come out?
Yes, we can.
Yes.
We are doing it actually.
You are doing it.
Yeah.
And again, every tool, if you think you have understood it properly, try to make a post. Try to post it. And also tag all of us here. So that way we will have, we'll form a good network of friends. At the same time, it will be a knowledge sharing, right? And that's the point. So DPMO can be calculated in any industry, be it manufacturing or let's say you are in accounts department, you are preparing invoice. Will you be able to calculate DPMO with respect to invoice
Yes.
preparation process
Yes.
also?
Yes.
Yes.
You have to define the defect opportunity. Customer name, if it goes wrong, that's a defect. Your GST number, if it goes wrong, that's also a defect. Your GST, customer GST, if the taxing is done wrongly, that's a defect. You define the defect opportunity, then you know how to calculate DPMO. And then you can convert that into sigma level. So I think that won't be a big challenge. Yeah. Any question anybody want to ask?
So the stage sixth one, that a DPMO calculation.
Here,
This one. Yes, sir. The defect per million opportunity is how to calculate this one. D value.
see, these are
This is okay.
all the questions, carry answer within the question. Defects per opportunity.
Yes,
Numerator is defect, denominator is total opportunity.
total opportunity. So, okay.
So defect is 22, total
10,
opportunity is
22.
150. 0.146. Defects per opportunity available, defects per million opportunity required.
Yes.
One apple is 1 rupee, so 100 apple will be 100 rupee.
Mm.
One apple 1 rupee, so 1 million apple will be 1 million rupees.
Okay. So 0.146
0.146
into.
multiplied by 1 million.
Okay.
That will be 1,46,000.
Okay.
So DPMO to sigma level conversion, all of you should be familiar with the sigma level calculator. So you can't do certain things manually. You can do, but then it will be time consuming.
Okay.
All right. So now we move on to process capability indices. Already I have taught you CP. When your process is just capable, what will be the CpCpk value?
1.
Is one.
When
One.
process is doubly capable, CpCpk will be 2.
2.
If your process is triply capable, CpCpk will be 3.
3.
A doubly capable process is nothing but a Six Sigma process.
Yes.
Yes.
When you get a CpCpk of 2, your process is operating at a Six Sigma performance. And here is the formula. USL minus LSL by Six Sigma. What is USL minus LSL? Specification
Upper
width.
specification,
What
upper
is Six
specification,
Sigma?
lower.
specification limit.
Six
Process
Sigma
width.
is process width. Because any process obviously will have 3 sigma variation on the right side, 3 sigma spread on the left side. The spread is always 6 sigma. So denominator is 6 sigma, but CP is specifically known as potential process capability ratio. Potential. It will not give you the actual capability. There is a limitation. To overcome the limitation, another metric is introduced, which is CpK. The CpK is known as process capability index. That will give you the real measure of the capability. But CP will give you potential measure of the capability. Now, all of you have a chance to score 100 marks in the exam. Am I correct?
Yes.
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 That is the potential capability. But what are you going to actually score? That is going to be different, isn't it?
Different. Yes.
100 is the potential. You can score 100. But what do you actually score? That is going to be the real capability.
Real cap.
So you always need 2 metrics, right? So here what happened? There is a process here. Look at the process. And I think now by looking at the process, you can immediately say, is it capable or not capable?
Yeah, it's
Process is
capable.
capable.
It's
capable.
capable. Because you are seeing the control limit inside the specification. And in order to measure the capability, you are using CP here. Specification width is 20, process width is 12.
12.
You can also calculate using the formula. You see here, USL minus LSL divided by UCL minus LCL. You can replace UCL minus LCL by 6 sigma. All are same. if you know, if you spend some time and you yourself calculate, you will be able to connect everything is same only finally, right? So now CP is 1.67. That means your process is capable. And there is also an industry standard recommended by AIAG, Automotive Industry Action Group. CpCpk should be 1.67 for critical process, 1.33 for less critical process.
Yes, critical.
And here it is 1.67. All of you are clear with CP here?
Yes.
Process is potentially capable as well as actually capable. Why I am saying actually capable? Because I could see from the graph,
Sure.
my control limit
Yes.
is inside. No rejection is possible. So when you want to understand the capability, only using CP, try to see the graph also. Otherwise, you need one more metric, which is CpK. I'll tell you why it is. See now, can you see the process shifted?
Yes.
Yes.
Here
Right,
process
right.
is not shifted, but here it is shifted. Now you use the same formula, USL minus LSL divided by UCL minus LCL. Every value is available. So again, it is giving 1.67. But is that process really capable now also after the shift?
No. No.
So CP is not capturing the shifting of the process. There is a limitation. The limitation is it doesn't take into account the process center. It only takes specification limit and control limit. That too, the difference in the control limit, difference in the specification limit. That is why CP is not a good indicator of capability. Whatever CP is telling you, that is only a potential measure of capability, not the real capability. This is the limitation. CP will work well if your process is not shifted, if your process is centered on the target. But the same CP will give a wrong estimation of the capability when your process is shifted. So to overcome this, we are introducing one more capability measure, which is known as CpK. So if the process is shifted, let's say the process is shifted to the right side, then the rejection will start happening on the right side. Am I right?
Yes.
Yes.
If the process is shifted to the left side, the rejection will happen on the right side.
Yeah.
Now, in order to understand whether this process is shifting or not, I want you to divide the specification width into two parts. Possible or not?
Yes,
Specification width is divided into two parts.
2 parts, yes.
The center point is X bar.
Yeah.
So now the specification width is divided into blue bar and green bar. What will be the length of blue bar? Difference between USL and X bar. Similarly, the length of green bar will be X bar minus LSL. Clear, all of you?
Why it is green, sir?
I like green color.
Okay.
You can change it to some other color.
Okay. Okay.
Yeah. So green is universal color. Now coming here, process width. Process width is always 6 sigma. I want to divide that also. So right side it is 3 sigma, left side it is 3 sigma. All right.
Okay.
Okay. So now you find out a ratio on the right side, ratio on the left side. See, earlier we calculated total ratio, isn't it? Total specification width divided by total process width. Now CpK is asking you to find out half of the specification width on the right side divided by half of the process width on the right side. Half of the specification width on the right side. What is the formula?
USL minus X bar.
Yeah, that is taken. That is divided by 3 sigma. Similarly, half of the specification width on the left side divided by 3 sigma. Both sides I am getting the same value. If I am getting the same value, it is a confirmation that my process is not shifted. All right. My process is not shifted. So CP right side, it is known as CP upper. Left side, it is known as CP lower. Sometimes in the book, it is written as Z upper, Z lower. Both are same. CP upper, CP lower, or Z upper, Z lower. When both are equal, CP upper, CP lower, what does it mean? Process is
Not
not shifted.
Not shifted.
When process is not shifted, CP and CpK will be equal. That's the ultimate scenario of capability. The ultimate scenario of capability is CP equal to CpK. Your process has reached the potential. Imagine you scoring 100 marks in the exam. The potential is 100 and you also scored 100. You have reached the ultimate, isn't it? Then we will increase your target. Something like that. So now CpK is 1.66. Now imagine the process is shifted. Can you see the process shifted now?
Yes.
Yeah.
Now which side the risk is increasing? Right side or left side? The right side risk has increased. Am I right? Can you see the control limit approaching the specification limit?
Yes.
So your CP upper will fall down. You can see that. Can you see that? You use the same formula, same values. Only thing is process is shifted now. USL minus X bar by 3 sigma. Now your CP upper is falling down. Earlier it was 1.66. Now it has become 0.8.
Yes.
But left side, your CP lower has become more healthier now. So for CpK, you have to pick up the lowest one because the lowest one, the minimum one, indicates the problem, right? So CpK is nothing but always minimum of the two value. So 0.833 is the CpK. And any CpK value less than 1.67 is unacceptable for critical process. For other process, CpK value less than 1.33 is unacceptable. Though 1 itself is okay, but 1.33 is minimum required. And for critical process, 1.67 is minimum required. Hope all of you understand CP and CpK. Am I right?
Yes.
A tough concept, I think, is now easier to all of you. So look here, this is the condition to be satisfied. CpK should be more than 1.66 or 67. When
No.
CpK is more than 1.67, your CP will obviously be more than 1.67. Is my statement correct?
Yeah.
CpK is more than 1.67. Your CP will obviously definitely more than 1.67. The
Yes.
statement is true, right?
Yes.
So just look at the CpK always to comment about the capability. Don't look at CP. If CpK is good, your CP will automatically good. Hereafter, if you want to understand the capability, look at CpK, not CP. Hope it is clear to all of you. And
Yes.
we expect 1.67 or 1.66 for critical process. For non-critical process, 1.33. Moreover, if this condition is satisfied, aim for making the CpK equal to CP. If this condition is satisfied, aim for CpK equal to CP. If CpK equal to CP, you have reached the ultimate performance, ultimate capability. All of you want the ultimate capability, right? In your process, what is possible you want to achieve. That means your CP must be equal to CpK. Whenever CP is not equal to CpK, what do you understand out of it? Can one of you answer this question? When CP is not equal to CpK, what do you understand out of it? You have
Process
not
not
reached
good.
the ultimate
not
capability.
Not capable.
No, you can't say. Please use the words very, very carefully. You're all going to be called as green belt and black belt. Don't think that all the words will give same meaning. If you say, when CP is not equal to CpK, it doesn't mean your process is not capable. There can be a situation where CP is not equal to CpK, but still CpK may be more than 1.67.
Critical.
No, it is not centrally located.
Process is capable, but
No.
still, it is slightly shifted.
Shifted.
Yes.
Process is capable, but still it is shifted. So when you shift the process back to the target, capability will go to the next level. Isn't it? So when
Yes.
CP is not equal to CpK, it means further possibility for improving the capability exists.
Sir, one clarification here. So when the process shift is happening, is it like we can correlate to the variation happening in the data set?
See, there are if the variation increases, if the variation at the input side increases, it can affect your process. If your process is affected, the spread can increase.
True, sir. Agree. Why I'm asking this question is I'll tell you. Generally, in a pharmaceutical product, the major criteria for us is to maintain the moisture at a desired level. So during the manufacturing and post manufacturing also, when we are keeping the product, we normally measure moisture as one of the criteria to ensure or to give a confirmation or assurance to the customer that the product is stable. Because once the moisture comes into the product, always there is a possibility that moisture will deteriorate the product. With respect to that, I'm asking whether.
No, correct. See, moisture, I don't know, moisture content is your X variable, I believe, right?
Yes.
You are talking about X variable, and that, okay. Probably we'll talk about the X variable during the analyze phase. Now we are measuring our Y. Now we are measuring our Y, that is our output variable we are measuring. And if the output is within the spec or out of spec, that is the question. And see here, let us stay, keep the example very simple. Imagine we conduct an examination here. All the black belts here, they write an exam. The batch will have an average mark. Am I right? Our normal average mark is, let us say 80%. What is the average score of our past student? 80%. Now this batch, average mark is found to be 65%. What does it indicate? This batch performance is lower than past history.
Previous.
That means this time the process is shifted to the left side. When the process is shifted to the left side, some serious mistake has happened. Either the topics are not covered properly, or the majority of the students did not attend properly. Major problem. Can you see that? That's why the entire process itself is shifted. If everything goes in the proper manner, but still the number of failures are more. What does it mean? The average mark is 80 only. Average mark is 80 only, but then the number of failures are more. That means the variation is too high. The variation on left side is too high. So there are two possibilities. One is your average itself can get shifted. Another thing is, see, sometimes what happens when both side problem happens equally, then average will not get affected. Do you understand? Average will not get affected, but the spread will alone increase. So right side, it will go beyond upper spec. Left side, it will go beyond lower spec. But still, if you calculate average, it will come to the target only. So average sometimes may not get affected, but spread will increase. So that's why, we need to look at both. So here we are talking about CpK. CpK also takes into account your process shift. But Cp takes into account only spread. That's why CpK has to be more than 1.67 to conclude our process as capable. But if Cp is different from CpK, it is letting you understand that you can further improve the process. That's the point you need to understand. Further improvement is possible whenever Cp is different from CpK, and Cp will always be higher than CpK. All of you understand?
Okay.
You have done a project, you improved CpK, but in the same project you understood that Cp is much better than CpK. Then the same project can be floated one more time to improve the CpK further. One project is giving direction for another project. Do you understand?
Yes.
That's how you all have to use Cp and CpK. Now I want all of you to open the sigma level calculator. Please open your sigma level calculator and we are going to solve these scenarios. All of you, do you have the sigma level calculator Excel file with you? I have already given.
No, sir.
Yes, sir.
Oh,
Yes.
few of you, okay. For the benefit of those few, it will be again shared in the group. I think it is there in the group only.
Yeah.
Even one of you can repost it, or I will search and I myself will repost. Sigma level. But all of you please open. Maybe I will stop sharing because answer is there. I'll tell the question, you all have to work out like the previous one, yield. Okay, sigma level calculator. I'm posting it again in the same group. VB33 and one more group. So now all of you should be able to see the same Excel file in the WhatsApp group. Please download and open it. Now I will give you the scenario. Please tell me, are you ready with the Excel file?
Yes, sir.
Now
Yes,
you
sir.
got to listen to me very carefully and write down the numbers, and then finally you are going to put it in the Excel calculator, and you are going to tell me the CpCpk value, and you are going to make the conclusion also. I will ask you whether the process is capable or not. I will also ask you whether the process can be improved further or not. Right? So now, this is about the reimbursement process. All of you know reimbursement process, right? The health insurance and many places, or in company itself, people can submit the bill and then reimbursement happens. And customer expect a response or a response within 30 minutes. The response time should be within 30 minutes. Every time I upload my documents, a decision has to be taken within 30 minutes. Yes, your claim is accepted and it will be reimbursed. Or otherwise, the decision will be your claim is not accepted because of the problem. 1, 2, 3, 4. You are requested to resubmit. So this kind of response has to come, right? And so far, the past history says that normally the response time, or people sometimes call it transaction time. Let's say the transaction time, the average transaction time is 22.09 minutes. Please note down this number. So far, the track record says the average transaction time is 22.09 minutes with a standard deviation of 5.96 minutes. All of you are noting this?
Yes, sir.
Average transaction time is 22.09 minutes with a standard deviation of 5.96 minutes. And the transaction expectation is it must be completed within 30 minutes.
Yeah.
So what is the upper specification limit for the transaction time?
30.
30.
Lower specification limit?
16.13.
0, sir.
0.
0.
Lower spec is 0, upper spec is 30, average transaction time is 22, standard deviation is 5.96. For this condition, you need to find out Cp and Cpk. Let me see who can do it fast and who can.
CP is
CP is
0.83.
0.83.
is 0.8.
CPK is 0.44.
Wow, CP is
0.83.
0.83, right? CPK is
0.88.
0.44, sir.
0.44.
0.442 is the correct answer. 0.8 and 0.4. Now tell me, is this process capable?
No.
No.
Not capable. And what are you supposed to do to make it capable? Will you focus on shifting the process to the target, or will you focus on reducing the variation? These are the two things you should do.
Yeah.
What will you do? Or do you have to do both? You have to do
Sir,
both in this case. Because your
Sir.
CPK is in trouble. Can you see that?
Yes, sir.
Yeah,
Your
0.4.
CPK in trouble. First of
Less
all,
than.
CP in trouble. If CP is in trouble, the spread itself is too high.
Okay.
So the remedy is reduce the variation. Reduce the variation.
Very-
And the CPK is also trouble and different from CP. Can you see that?
Yes.
Yeah,
When
half of that.
CPK is different, your process is shifted.
Yes.
You have to move it to the target.
Yes.
Target is always center point of USL and LSL. Target is always center point of USL and LSL. And now we are talking about a process which is sensitive on both sides. For a one-sided process, target is not the center point. That's a different subject. But right
Yes.
now, what we understand is the process should be shifted to the
Right.
target and variation must be reduced. Now, who is going to share the screen and demonstrate it for the benefit of all the participants. One of you please share your sigma level calculator and show the
Yes.
sheet name and demonstrate how you fed the information to get the CpCpk value. You can always do it manually. You can always use the Excel calculator. And this is easier and more accurate. There will not be any accuracy issue. There will not be any gauge R&R issue. Nothing will be there. So who is sharing?
Yeah, Saravanan.
Oh, Saravanan. Okay. And see here, Saravanan has opened the particular file name CpCpk calculator. Look here how he got the answer. USL is 30, LSL is 0. And process average is 22.09. Process standard deviation is 5.96. And so he got the CpCpk value. All of you are clear?
Yeah.
Yes, sir.
And looking at the
Sir.
CpK value, first conclusion is process is
1.33.
not capable.
Yes,
Why it is not capable? It is less than 1.67.
1.67.
If nothing is mentioned about criticality, always consider the process as critical. So less than 1.67, so process is not capable. Now remedy. Remedy, look at the CP. At least your CP, is it more than 1.67?
Yes.
No.
Yes.
No, 0.8.
It should
So
be-
the remedy is reduce variation. Can you please type, Saravanan, please type reduce variation. First remedy, reduce somewhere below, just below the yellow box, just below.
Yes, sir.
You type there. You can type. See here, it is mentioned. You type reduce variation.
Okay,
You should
1.
also use the same language in your workplace. You tell
Okay.
your team to reduce variation. You type reduce variation. You want to type here.
1
Wherever,
point.
some place you type reduce variation. I want all of you to see the word reduce variation. Okay, R is missing. This is one suggestion you should give as a Six Sigma green belt or a black belt. For people to understand your suggestion, they should know your language, isn't it? If you say
Yes.
reduce variation, what do you mean? You mean reduce
Variation
variation
would be
input.
reduced. Yes.
Reduce variation in the input, reduce variation in the process condition. So what will happen? Output variation will reduce.
Reduce.
If the variation reduces, you will see the impact, more impact on CP and some
Yes.
impact on CPK. That means your CP will improve, CPK will also slightly improve. Can all of you understand what will happen if you reduce variation?
Yes. So I have
Further
to-
suggestion number 2, move the process average. Type the next box. Number 1, you leave it. You type here. Number 2, second suggestion, move the process average.
Average.
Move the process average towards target. Towards target. Move the process average towards target. So what is your current average?
Average is 22.09.
22. What is the actual theoretical target? It should be at the center between USL, LSL. How much it is?
11.
Not 11. 0 and
1.0.
30. What is the midpoint?
Oh,
15.
midpoint
It's
is
a
15.
15.
15.
15.
Yes.
With respect to the 15, your average is 22. So your process is moved to the right side or left side?
What's left?
Left side. Left side.
Your process
right
has
side is
moved
there.
to the right side. Now you
Right
are
side.
going to move it back to the left, isn't it? You are
Left
going to
side,
move it
yes.
back to the
Left
target,
side.
right? So the shift happened is to the right side.
Yes.
Now you are going to adjust it. For that, the average of 22 will be brought to 15.
15.
15.
If you make these two things, your
Yes.
CP will go above 1.67. Your CP
Okay.
will also go above 1.67. And
Okay.
your problem would have got fixed now.
Okay, now I change.
We are only talking statistically, please understand. How they are going to reduce variation, how they are going to move the average, that is their headache. Am I right?
Yes.
They have to brainstorm, they have to make necessary changes in the process, but ultimately result will appear here. Clear, all of you?
Yes.
Now one more case.
Sir, Uttam here. But if we change the mean value into 15, it is not coming, sir. The CP and CPK value is not changing.
Okay, let him type. You change the mean to 15. Enter. Now CpK is
Half of it.
improving. Can you see?
Yes, 0.8.
Both are
But,
same.
but CP is not improving because CP doesn't consider average. CP doesn't consider process center.
Okay.
Okay.
Now you reduce the standard deviation.
Yes, here.
You make it 2.96 or something. 3.
Yes. Now
CP has increased.
increase.
But we are achieving the solution easily by changing the number. But in shop floor, in workplace, in your process,
Not this.
lot of efforts are required, isn't it?
Mhm.
Now one more problem. So I
Yes.
want maybe Saravanan can continue doing it.
Yes.
Now
Yes,
this
sir.
is an electronic manufacturing process. The current flow must be 100 plus or minus 10 ampere. What is this information?
That is, you are
Upper
giving
limit.
specification limits, upper and lower
100
limits.
plus or minus 10 ampere means upper
So
spec is
90 and 110. 110.
upper spec
110.
is
Now
110,
110.
lower
Yes.
spec is
90.
90.
90.
Hope you have typed it, right?
Yes.
Yes, correct.
Yeah, he has typed it. Now let me read, the further question. And now the process average is 107. Process average is 107.
Not
So standard deviation is 1.5. They are measuring current flow here, right? So variation in the current flow is 107 and 1.5. And now what is your comment now? Is this process capable?
No.
No,
No,
no.
not capable.
So, so what is the remedy?
Reduce variation.
Reduce variation. Is it required? Reduce variation. Please look at the numbers and speak appropriately.
2.2 CP.
Yes, my 105.
No, no.
We have to
107.
reduce
variation.
107.
We have to increase CpK.
50.
Like we have to make it.
See,
You have to
there is
bring
no problem with the CP.
Yes, only
That
CpK.
means you don't have to reduce variation.
Yes.
Move the mean.
Only the second condition is required. Move the process average towards target. That is the
Yes.
suggestion you should make. Variation is under
107.
control. CP is healthier. When CP is above 1.67, you no need to talk about the variation.
Okay.
All of you are clear?
Yes.
Now the process is not capable. I ask a question. When I asked you whether the process is capable, you said no. You said no. Now I ask another question. Is this process consistent?
No, sir.
No. Towards the left.
Because
have to
LSL, ESL can shift any side.
I heard a voice. Yes.
Left
Who is
side.
that? The lady voice.
Yes.
The answer is yes. The process is consistent, but you're not consistently good. You may be consistently bad. Possible, right? You're
Yes.
writing 10 exam. In all 10 exam, you are failing. You are not capable, but you are consistent. Possible, right? 10
Yes,
times, all 10 times you failed. You are consistent, but you are not capable. So that's the scenario here. CP is better, but CpK is not acceptable. So
Yeah.
process is consistent, but not capable. All of you understand? So don't
LCS
try to reduce the variation, rather push the average towards target.
Yes.
So any
That
question?
means we have to work on process control limits, right, sir?
You need to work on process
Process
average,
control
not on the
limit.
control
Average.
limit. Control limits are safer. Control
Okay.
limits are closer to the process center.
Yes.
Variation is less. That's why CP is better. You need to work on the process center. See, when average itself is shifted, there will be a
Yes.
special
Toward right
cost.
side.
There will be a special cost, and you can easily find out the reason. Say, for example, one student, a set of, see, the class average is 80. Class average is 8. But a set of 10 students, their average is 45. What do you understand? In your class, the class average is 80%.
Yeah.
But a set of 10 students, their average is only 45. What could be the reason with the 10 students? Does it mean that the teacher is not teaching well? If the teacher is not teaching well, the class average would have affected, right?
Yes,
Correct.
80%.
Class average is proper. But once
80%.
for the 10 students average, it is not good. That means definitely there is a problem with the 10 students.
Students.
Either they are not coming to the class, or they are not attending properly, or they are not doing their homework. So the reason, there will be a very obvious reason when your process average itself is shifted. Right? And you will be able to find it out with some brainstorming. Now, one more scenario. And now this time it is an extrusion process. All of you know extrusion, right?
Yes.
Yeah.
Every day morning, you all extrude the toothpaste from its, tube. Isn't it? When you press, the toothpaste comes out. That is called extrusion. So an extrusion die is used to produce aluminum rods. The diameter of the rod is a critical to quality characteristics. The specification is 0.5035 plus or minus 0.0010. Please type down this value. The
Plus or minus?
specification is 0.5035. You type it somewhere. The specification is 0.5035 plus or minus 0.0010. You can type it in two different columns. 0.5035 in one column, 0.0010 in another column. 0.5035. I said 0.5035 in one box.
Five 5035.
5035. And in another box, 0.0010. That means what will be your upper spec and lower spec here?
4550.
and 5025.
5035 is your upper and
Please
0.015.
type your upper spec. 0.5045 is your upper spec. There in the calculator straight away. Go to the calculator left side, blue color area. Upper spec is 0.5045.
5045.
And lower spec
45.
0.5045.
Right. This one.
0.5035. Sorry, 0.5025 now.
25.
Now further information about the process I'll give. Process average is 0.5031.
Process average?
0.5031.
0.503.
Yeah, 0.5031. Process standard deviation 0.0003. Now tell me what happens. 0.0003. 0.0003. Now, what is your understanding about the process? Are you happy
This
with
is not
your
capable.
CpK?
No, not capable.
Not capable.
Both are not
Both
capable.
CP and CPK need to improve.
Variation to be reduced.
Yes.
Variation has to be reduced because you are not happy with the CP. And CP and CpK, are they same, different?
Different.
So you have to move the process average
Yes.
towards target. Two action required. CP also under trouble, CpK also under trouble. So two action required. Reduce variation and then move the average. So that's it. So that means you are very clear with CP and CpK. Now one more question before we conclude. So let me share my screen. Yes, Saravanan, thank you. You
Yes,
can
sir.
stop sharing. Hope all of you are now clear how to use the sigma level calculator. This will be very, very helpful even during exam, even during your project. You just have to pick up the information and use it properly here. If the input is good, then the output will come accurately. And now what is your answer to this question?
CP is 0.94, CpK 0.33. And if the process is not capable, what action need to be? Improve the capability.
Move process average towards the target.
Yeah.
Need to reduce variation and also
Reduce the variation and
bring
Move toward
average
the target.
closer to the target.
All of you have become the experts now. When to use reduce variation, when to move the process average. You are only saying, reduce variation and, move the process average. But how to reduce variation? That's a technical question. We are not, speaking the technology here. We are only talking about the process improvement methodology, right? And what needs to be done to reduce the variation? What needs to be done to shift the process average? That has to be evolved by involving the team, right? That's called, the solution. So please read all these lines and tell me whether you're okay with all the lines. That means the measure is over. Okay,
Yes, sir. Okay.
all good. That means measure is over. So we have 10 more minutes. So now let us also capitalize on this 10 minutes. What is the next phase?
Analysis.
Analysis, analyze. Now we have the baseline. We have already set the target in the defined phase. Hope all of you remember the target, right? You wrote it, goal statement. The target is available, baseline is available. Now you look at the difference between the goal and the baseline, target and the baseline. This is called a gap in performance according to your project. The real gap in performance is now understood after completing the measure phase. Am I correct? What you have written during the define phase, that is only, assumption. The reality, you will come to know only after the measure phase. All of you understand what I'm speaking? That means the problem itself is validated now only. Can you see that, all of you? Do you understand or not? In define phase, you told rejection rate is 1.5%. But now you realize your rejection rate is not 1.5%. The rejection rate is 6.8%. Possible or not?
Yes. Yes.
Earlier,
Possible.
the company has calculated the traditional yield. According to the traditional yield, the rejection is how much? Just 1.5%. But now, when you calculate the first pass yield, you now realize the rejection is not 1.5%. The rejection is 6.8%. The problem is now 4 times bigger. Am I right?
Right.
Yes.
And the benefits will also be 4 times, better now. This is one way. Using a wrong tool for measuring the baseline, could be one reason. Another reason could be, the measurement. After you actually collect the data straight away, earlier it was a mere assumption. People were simply orally telling there is no actual data, or they might be having a data which is collected using a poor measurement system. But now you have validated the measurement system, isn't it? When you validate the measurement system, there will be more visibility. Am I correct or not?
Yes.
Yeah.
So by correcting the measurement system and by using a proper tools, you are now validating the problem itself, and the real gap in performance is understood. Now, what is the reason for the gap in performance? Who is the culprit? I mean the root cause. Whether the root cause is just one or the root causes are many. If there are many root causes, exactly how many? And if the exact number is understood, what is the contribution of each of the factor? These are the questions you must answer in the analyze phase. Do you understand? What is the root cause? Or, what are the root causes? And how many root causes? And what is the contribution of each of the root causes? When you say root cause, that means that factor is the culprit. That factor is the culprit. Imagine a criminal case. Criminal case, a crime has happened. And the culprit has to be found out. Now you are the police department. How will you investigate? You will first of all, you will go to the spot. Am I right? The crime has happened. And you go to the spot and you see that in that particular time period when the crime has happened, 100 people were there in the place. That means as a police, you will start suspecting each of the 100 people, isn't it? Like your school teacher checking every student's bag. When something is, missed in a class, what the teacher will do? Teacher
All
will
students.
check each and every student's bag. The geometry box is missing. Now all 60 students' bag will be checked. Am I correct?
Yes.
The same manner, the police department will be noting down all 100 people who were present in that particular time period. The list of all 100 people is known as the probable cause factors. This is known as probable cause. Sometimes it is known as possible cause. What does it mean? When I say probable cause, what does it mean? The culprit is inside that particular group. Am I right? Definitely the culprit is within this 100. That is the, the police strong belief. Am I correct?
Yes.
This is the first step towards finding the root cause. What is the first step? Listing out
Listing out the
probable
measurement.
cause factors. What is the other name for probable cause factor? Possible cause factor.
Possible cause factor.
You either call it probable cause factor or you call it possible cause factor. Do anything that is possible to create a list for yourself. Police department, what the police department will do? They go to the spot, they refer to the CCTV footage, they talk to people, including the, including the potential one, including the possible one. They also talk to the nearby shop fellows. Am I right? You should also do the same thing. You go to the place where the process is happening. Do some observation. What went wrong? And try to note down everything. Talk to the operator, talk to the line supervisor, talk to the quality inspector. Talk to the relevant people. And if required, call all of them. Give them a cup of coffee. Some snacks. That is known as brainstorming, isn't it? Yes or no?
Yes.
Call all relevant people and explain the problem and see, and then you seek their opinion to list down the causes, possible causes or the probable causes. That is known as brainstorming. Now you have an Excel file where a complete column talking about more than 50 different causes. How many causes you are able to list down? 50 different causes. And you can be very efficient. You can be very efficient and even effective if you define the problem one more time, in a very, properly. Already you defined the problem. Now you have to describe it again to all the group members who are sitting in the brainstorming hall. Because you need their support, you need their input. You want everybody to speak, isn't it? Because their inputs are important to you. That matters a lot to you. So you explain the problem in a way that they are motivated to speak. Redefine the problem. Why I ask you to redefine the problem? Because now you have data. What you have written in the define phase, that you forget. Now the numbers are different, isn't it? You explain everything and also tell the group member, understand the consequence if we don't address this problem properly. Our organization will be losing a huge money and our customers might cancel the contract and some of us might lose the job. Isn't it? So this is the exact scenario we are sitting. Now tell me, we really need your input, your valuable input, so that we can find out the culprit. We can find out the root cause. So brainstorming. And then there is one more beautiful tool known as cause and effect diagram. Have you used it? I'm sure all of you should have used it. Am I right? Cause and effect diagram. Fishbone diagram. The fishbone diagram is nothing but visualization of the information collected during brainstorming. Am I right? So my voice is gone. Is it so?
Yeah, okay, now it's.
Internet connection is little unstable. So you listed all causes and in a notebook, and people still don't have the clarity. Ultimately, you are going to derive the solution involving the same set of people only. And if you write everything secretly in a notebook, how are you going to derive solution from them? Instead, you present it in the board, in a bigger board, that too in the form of a diagram. Then even a layman will clearly understand how the problem is caused by certain factor. Am I correct or not?
Correct.
How tree is getting water. You are showing the roots, and roots are going to many places. And now even a layman understand how the tree is getting water. Isn't it? The same manner. How the problem is happening. What are the roots of the problem? What are the causes? How many possibilities are there? Everything is now visualized. And again, to bring more clarity, you are now dividing the causes into categories. Possible, right? Suppose if training is not going on properly, there are several reasons why training is not going on properly. Trainers are not good. Material is not good. The training platform is not good. The examination pattern is not good. Possibilities, isn't it? So I will categorize reasons. Certain reasons will come under the course material. Certain reasons will come under faculty. Certain reasons will come under the participants. If the participants themselves are not motivated enough to learn, then training will not go on properly. And certain reasons can be articulated to the platform, the poor internet connectivity, poor facilities to interact. So when I categorize, my people will better understand the problem, isn't it? Because ultimately you are going to get the problem solved with the involvement of the same set of people. So you have to make them clearly understand the problem. This is what all of you are doing with the help of a fishbone diagram. Fishbone diagram does nothing than visualizing the causes. Am I right? Fishbone diagram, we call it root cause analysis, but it is only a visualization tool. It visualizes all the causes. At the same time, it categorizes them into some more appropriate headers. Sometimes it is 6M. Men, machine, method, measurement. And then, what are the 6Ms? Men,
Mother
material,
environment.
method, measurement, mother nature, and one more. 6M. Find out. Men, machine, machine. Men, machine, method,
Material, method,
and measurement and mother nature. So these are the 6Ms popularly used, but absolutely there is no rule to have all 6Ms. There is no rule to have even a single M. What is relevant, heading, you put that. For software development, it can be, 4 different headings. For medical field, it can be 3 different headings. For training, it can be a 4 heading problem or a 5 heading problem. So you just, use the headings in an appropriate manner. And now people get a clear idea about how things can go wrong. This is known as step number 7. Is it clear to all of you? What is the outcome of step number 7? List of possible factors or probable factor. X1, X2, X3, X4, up to X50 is now very, very clear to you. But we are not very clear which is going to be the root cause. All of you are with me so far?
yes, sir.
We'll continue from here. How is our journey going to be from here to further? From the probable or possible cause to the next set, potential cause. Police people will only take 5 or 10 people in their jeep. Will carry only 5 or 10 in their jeep and these 5 or 10 will be taken to the police station. Have you seen that? If a crime happens, they don't arrest all 100 people. They don't bring a lorry and then take all 100. No, they always bring a jeep and then take only 5 to 10 people. Have you seen that?
Yes.
Only the detailed investigation is required only on vital factors,
Particular.
the trivial factors. Now you have to segregate the trivial many into vital few. Some techniques possible, and that is next step. Now when you separate out 5 to 10 factors from the 50, the 5 to 10 is known as potential root causes. 5 to 10 is known as potential root causes. Now, for each of the potential root cause, investigation at the next level will happen. You know how the next level of investigation will be inside a police station, isn't it? They have never gone inside, so we don't have the experience. But definitely the investigation will be very intensive. Am I right?
Yes.
So we are also going to change our approach. So far, we have been very subjective. We are discussing. But we will change our approach from discussion mode to experimentation mode for validating the potential root causes. Not all potential root causes are root causes, but definitely root cause is there inside. So I will validate all the 10 one by one. Out of the 10, 3 or 4 will get validated as the root cause. Let's say out of the 8, 3 gets validated. That means, the suspect is proved. How? Through experimentation, not by opinion. Through experimentation. That experimental procedure is known as hypothesis testing. Tomorrow morning fresh, I will be teaching you. Experimentally validating the root cause. That is known as hypothesis testing. And once the root cause is validated, then we will check the contribution of each of the factor. Which is the major contributor? That means a group leader, gang leader. Crime has happened, 3 people together done the crime. Definitely one person will be the gang leader. Who is that person? Who is that culprit? Same manner. There are 3 root causes. Which is the major contributing root cause? Which is next? Which is next? Is that all the 3, if I fix, my problem will get solved. This is known as sufficiency. So, possible factor to possible root cause. Next move is potential root cause, then validated root cause, and we are checking the sufficiency. This is the journey you will be going through in the analyze phase. For that purpose, you must master another important tool known as hypothesis testing. Tomorrow morning, 9 o'clock sharp, we'll talk about it. I think that will be the ideal time. All right.
Right.
Thank you so much, all of you, for spending your whole day's time. That too in a very interactive manner. I hope everyone is active today, though you are not on video, but still I believe everyone participated actively. And if you understand hypothesis testing and further tools, your perception will completely change and you will feel more confident while solving problems. All right. I just stop here. Maybe RK